Good afternoon, everybody. Welcome to our auditorium. My name is U.Porto. I'm organizing the workshop. I'd like to greet Professor João Falcão Cunha, Dean of the Faculty of Engineering, dear members of the Representative Board and dear members of the Executive Board, distinct guests, Professor Valente Oliveira and Engenheiro Carlos Moreira da Silva, distinct keynote speakers, Professor Stephen Beck, John Mitchell, Professor Ewan Lindsay, Professor Alderkamp, and Professor Francisco Vasque, dear directors of the services, dear colleagues, ladies and gentlemen, thank you for coming to the workshop on the future of engineering education, which we are hopeful that will be a fruitful day or afternoon, and that will be also a nice start for a good discussion on what we'd like for the future. Professor Falcão Cunha, I ask you to come here to make our opening. Thank you.
Good afternoon, everyone who's here in the auditorium and the people who are following us in the Help channel at distance. Welcome to this workshop, and I would like to thank the colleagues João Pedro Pego and Ana Freitas, and also Cristina Soares for organizing this event, and everyone involved. I'm not going to repeat the words of João Pedro Pego, so thank you for all the guests who are here. In particular, I would like to say that this workshop was an idea of our friend and colleague Carlos Moreira da Silva, who suggested we organize this, so thank you very much for the idea. We have with us also the people who are leading the changes of the future of the School of Engineering. We have also the representatives of the students and the departments and services. And the main goal is to learn from the good experiences and to learn from the discussion that will follow. I would also like to say that we'll have a discussion who's going to be coordinated by António Beir Reis, who was a PhD candidate here. He is now working, and he came here for this purpose also. We also have a project of changing education at FEUP and, of course, improving it. We have had a big change this year with the adaptation, that's the political word for changing and creating new bachelor and master programs from the integrated masters. But this has been a chance to change curriculum and to change many things in our programs. And we hope to improve them. I'm sure we will improve them. This workshop will be relevant for that also. We also have a program, a project of having new space for interdisciplinary labs, new spaces for study, work, research, and this project also will benefit, I hope, not only from the presentations, but from the discussions we'll have. And this is a summary of many things which are important, but without further ado, I would like to thank again all the guests, the audience, and let's go. Thank you very much.
I called to the stage Professor Stephen Beck. He's coming from the University of Sheffield in the UK, and he was faculty director of learning and teaching, and currently is the headship of multidisciplinary engineering education. And this department delivers in a very innovative way the practical engineering teaching for the Faculty of Engineering in the Diamond Building. Thank you very much for being with us.
Good. Hi, welcome everyone. Good. So as he said, I'm Stephen Beck, and I'm going to talk about a couple of things which I hope will interest you. So one of the things that happened when we first started creating buildings and what came out of the diamond was, how big does it have to be? And one of the things that we want to think about is not just how big it is, but how the size reflects what we want to do and what our cohorts look like. So this is some work I've been sort of doing post hoc. So we built the building, and then I thought, how could we have designed it more carefully in terms of the size of the laboratories and what they're for and the size of the buildings. This also ties in with some extra work, some work that we're doing currently on finding out why students want to attend labs. So we've sent some questionnaires to students and staff to ask them what they think the labs are for, why they attend the labs, and also why they don't. There's a lot of work that's been done in the literature on lectures and why people attend and why they don't, but no one's done any work on labs. So we've been asking them about that. And these are some preliminary results. We've got ethical approval for them, so don't worry. So when we asked our students what they thought the labs, what they thought their experiments are for, we asked them various things. But the two bits that come out on top are to give them a practical experience, to actually let them do something, and also to reinforce lecture material. So this is what the students think. Interestingly, the staff think themselves that this is what they think labs are for. But when you ask the staff what they thought students thought they were for, they said it was to get marks. So what we find out is that staff view of what students value isn't necessarily what we think that they're for. So we also asked them what was most likely to make them attend the labs. And surprisingly, it's not counting towards the grade or clear instructions or open ends, but it's more interesting, more fun, and it's better integration with the lecture course. So what we actually find there is that if we can make labs that are attractive for students, if we can make them want to turn up, they're more likely to attend. And if we're able, and remember this is what the students think, and the students at Sheffield, as you'll find out from my analysis, are more experienced in getting labs which can integrate with the lecture course. They think that this is a really important activity. So I call this immediacy. And if you look at my first year aerodynamics course, which I taught last semester, what you find is that there are my topics down there, and then I have a series of laboratories that go with them. And what you find is that when I introduce a topic, the students come in and they play around with that topic. So in that, whatever we are, 10-week exams, 11-week exams, they have 1, 2, 3, 4, 5, 6 laboratories. And this means that whenever I introduce a topic, the students are able to come in and do some practical activities around that topic. So once again, I've coloured it there in rainbow colours because that's what we do these days. And so what they do is, when I introduce something, they experiment on it. Because it's built in to the lectures, they know the background before they go in to it from the course. The experiment contextualizes the subject. So when I'm talking about flow down pipes or drag on an object, I've told them about it, and in those same weeks they are coming in and experiencing it for themselves. I've got about 200 aerospace students on my course, and so how can I go about doing this? What is the construct? How do I think about labs? How does the facilities that we have tie in with being able to do this? One of the things is short labs. If you ask students, once again this came out of the analysis that we've done, how long they think labs should last, they think they should be about 2 hours. So once again, the 4-hour lab is a waste of time. After about 2 hours, people lose the will to live entirely. So they're not, because I have short labs, I can get more people through. Because they come in prepared already, partly because I'm lecturing on the subject, and partly because we force the students to do a pre-lab before they come in each time, they come in prepared, so they know what the theory is and what they want to do. And this crucial and last thing is that we have multiples of equipment. I call this on being the right size because I quite like this quote. I apologize to any vegans. You can drop a mouse down a 1,000-yard mine shaft, and on arriving at the bottom, it gets a slight shock and walks away. A rat is killed, a man is broken, a horse splashes. So this shows that depending on what size you're working at, you get different effects for the same cause. One of the subjects I teach, if you look down that list, is dimensional analysis, and this is all about it. What is the right size? What is the right scale? How do we move between different scales? And what's the effect on things? So, if we look at the way laboratories are run in most establishments, and I was talking to some of the people here over lunch, and I think this is very much the model that's run here. It's what we call a cottage industry. It's done at small scale by artisans. And it's normally run by the lecturer for their course. They've got 1 or 2 sets of equipment, and students will rotate round these over a year or a semester. So the students may do the experiment at any time. So they come in, get given a sheet, and that introduces them to the experiment. So already they have to get the context given to them. Things are going to work a lot slower. for them. They may be 6 months away from when they were taught the material, or they may not be being taught the material for another 6 months. So these things have got to be freestanding and independent. They can't be part of a scheme. So wouldn't it be better if they did the lab as they learned about the topics? And what I'm going to look for now going forward is, what does this mean in terms of the number of sets of experimental kit you need, the time taken to do the work, and indeed how you organize a timetable. So I know that we're engineers, or most of us are engineers, and engineers love equations and engineers love graphs. So what I've tried to do is put something that sort of came to me heuristically and sort of serendipitously, and put some numbers into it. So I've got here an equation. W equals S over G times N times L, where W is the number of weeks it takes to get the students through, all of the students through a given laboratory. N is the number of sets of kit that you've purchased. L is the number of lab sessions per week. S is the number of students in the cohort, and G is the number of students per experimental rig. So if we have this experiment or this equation, we can see what does that mean in terms of us designing our laboratories. So if we've got one set of kit and 2 lab sessions, 120 students, and we put people in groups of 4, it'll take 15 weeks, because this is a typical number that we may see in many universities. It'll take us about 15 weeks to get the students through a given experiment. Once again, because we have this, we can draw a graph of a number of weeks it takes to get through against sets of kit. So we can see, as we increase the number of sets of kit along the bottom there, that the amount of time it takes to get the students through drops. We can also rearrange that to see how many sets of kit we need if we've got a plan, if we've got a certain number of students, want to get them through in a certain amount of time, students per rig, etc. We can do the same sort of thing to say how much equipment we need to buy. Once again, this graph is identical to the previous one, but the axes are swapped. I'm clever. We can also look at the kit utilization. So that's how many times each bit of kit is used per year. So what we're able to do here then is we're able, in effect, to start putting financial numbers into it. So if we say we've got so much money to buy kit and we need to use it so many times, we can put a cost to it as well. So what we're able to say there is the number of times it's used per year is the number of weeks it takes to get the students through times the number of lab sessions per week. So once again, we can start sitting down and start sizing things, start sizing how much kit we need in order to get the students through. Once again, we can put some numbers in. If we want to get all our students through in 1 week, if we've got 4 lab sessions per week, then if in the previous example, each of our 15 sets of kit is used 4 times per year. So you can say, we're going to use this 4 times per year with this equipment. So once again, we can draw a graph, straight line graph here in this case, with the number of times it's used per year times the number of weeks it takes to get through. What we can then do is look at the kit utilization again. So by using those 2 equations we've got, we can work out how many weeks it takes to get the students through. We can also do a bit of substitution with our top 2 equations. I've given you T equals W times L and W equals S over G times L times N. Substitute in, and we get this bottom equation, T equals S over G times N. So the amount of time it takes to the number of times you use a piece of kit is equal to the number of students divided by the group size and the numbers of times you use that over the year. So using this equation, we can increase the kit utilization, T, by having either less sets of kit, N, which we know from our previous equation means it takes longer to get the students through, Smaller groups, so if we have less students in each group, we use it more times, or we can get more students through. So once again, we have these ones, but they're also ameliorated by those other equations. We've shown that having less sets is poor for the student experience, and larger groups are worse. So the only way we can increase utilization while preserving immediacy is to have more students. Now, people want more students, but it might be difficult to increase a cohort size. So where else can we find our students from? So why don't we look at other departments in your faculty? So instead of just thinking about the mechanical engineers or the bioengineers or the aerospace engineers or the electrical engineers, why don't we think about all of the engineers? So we have to now then scratch below the surface of what we think about as practical experience. And actually, if you do scratch below that, you might think it's different if you're learning about, well, my subject's fluid flow, from the point of view of a chemical engineer or a mechanical engineer or a civil engineer, but actually it's the same sort of thing. You've got a pipe, you measure the flow rate down it, you check what the pressure drop is. Whether you're talking about Pascal or kilopascal or meters of height is a matter of detail, but the fundamentals of what you're trying to do are the same. So why not share the equipment? So if you actually think, what are we trying to do, not how am I delivering this lab, or I've got to do it this way, you'll find that there are a lot of commonalities between what people are teaching. So why don't you celebrate those commonalities and go, we'll share this equipment. So my pressure loss down pipes, one's done by at least 5 courses. Chemical engineers, civil engineers, mechanicals, bios, aeros. So instead of 240 students that I have on my aero course, we suddenly have 1,000 students. So once again, we can write this, we can show this graphically with this here plot on the right. So if we put students through in 2 weeks, we'll use each piece about 40 times over the year, but using 1,000 students instead of that. So what we can do then is, as we bring more departments in, because we use them at different times of year, we can get that utilization up of the same numbers of equipment. So what we're seeing then is we can scale up, and by scaling up and sharing, we can get greater utilization. Suddenly the economics of changing your labs from the cottage industry to an industrialized form become clear. I love my titles. Sharing is caring. So as well as sharing equipment, we can share our teaching material. Instead of writing a lab sheet for flow down pipes or linear circuits 5 times, why not do it once really well and then run it out over 1,000 students? It may require some tweaking. You might have to change the nomenclature. I know, for example, as I said, as a mechanical engineer, I use pressure in pascals. Civil engineers use meters because it has to follow the contours of the land. That's a trivial tweak compared to preparing all of the learning materials, etc. So we can share teaching material, we can share staff. So instead of 5 different staff writing the lab sheet, get one staff member to do it once properly. And so we can share equipment, teaching material, staff, and also all of that infrastructure that goes through it. So share, work together, and you only have to do things once instead of multiples of times. So at Sheffield, let me just see how I'm doing for time. 4 minutes, I'm doing great. These are the student numbers that we have roughly at Sheffield. Aero, civil, they're all in these numbers. And what we see is that, give or take, these all come out to about multiples of 80. So 80 is my magic number, no need for 3 or 13 or 9. So we just write these in terms of multiples. So we say how many students we've got in the year. That comes out roughly to our quanta somewhere between 1 and 4, depending on what group you've got. And that then tells you how to get students through your laboratories. So if you want to, which we've done at Sheffield, make our laboratories in multiples or quanta of 80, then we can run through those labs like that. So we've got the structures lab, the fluids lab, thermodynamics and dynamics, etc., all at 80. Some of them didn't quite work, but I'm on the plot for that, the warpath. So once again, what we can do then is we can timetable things in groups of 80 and just move them around in chunks. The other thing is, once we've got a timetable slot for labs, my first year aero students, they could be doing my fluids experiment, but they could, oh, sorry, that shouldn't be aero, that should have been thermo and dynamics. They could also be in the structures lab and the thermodynamics lab. All of them are doing the labs at the same time. We know how they're doing that. We can timetable them, we can get them all through. And that means that instead of timetabling individual students to be here, there, and everywhere, you can work in big chunks of students and move them around. This is also of interest if you're building other spaces. As well as the labs being in multiples of 80, why not make all your rooms in multiples of 80? Because then if the lump of students can fit in this one, they can fit in that one. So my lecture theatres I designed also with the fingers of one hand in terms of quanta, so we could fit those cohorts into them. So once again, fit everything to the same size, and it works. Our workroom is also multiples of 80. So if you put all three workrooms, you get the students, you can fit the whole cohort in. Things break down slightly, but these are details I ignore in my talks. So when you timetable things, you can timetable students in lumps across the lab. So you could hand the building, as it were, over to a certain cohort at a certain time, and they can use it. So it makes timetabling relatively straightforward, because you've got these huge groups. You don't need to squeeze them into lots of little spaces and lots of little times. So you get a high utilization of space, equipment, staff, etc. It looks perfect on this screen. It looks rubbish on this screen. What you see is that those are students working away in the fluids lab. We've got 20 sets of kit, 80 students doing the same thing at the same time. 4 sessions again, gets all the mechanical engineers through. There we are, fluids lab, 80 students working away. Look at those happy students. We had to pay them a lot of money for that. So once again, even things which we have more specialized, we've still tried to build at scale. So we've got 4 wind tunnels, so we can get 20 students through, so they can do that. So once again, think of scale, think of sharing them. I could talk about efficiency as well. I have 38 seconds, so I shall talk about this. This is our flume. We only have one of them. It's used by civil engineers for open channel flow. But when I was teaching dimensional analysis, I wanted an experiment to teach dimensional analysis. So I thought, why don't we use the flume? Because then I won't need to use Reynolds number. I can use Froude number. And for those of you in fluid mechanics, everything is Reynolds number. So I was trying something else. So what I got the students to do was to calibrate on the little rigs, each of them separately, calibrate on the little rigs, a weir, and then predict what was going to happen on the big rig. So they used all of the 20 little ones, did one experiment on the big rig. So because it was bought for the civil engineers, it could be used for the civil engineers, but I had it available to introduce something new to the mechanical engineers. So we get that multiple of sharing as well. The other thing this ties down to, which is going to be my last slide, is that when we ask the students what they want things to be more fun. And one of the things that we're aiming for to make things more fun is gamification. So can you think about things in terms of games, in terms of fun? And here they are, they're predicting what's going on, and they're seeing how well they're going to do that. Not only do they understand the dimensional analysis, not only do they use some equipment they wouldn't have used before, but they actually enjoy it, they're testing themselves, they can compare themselves to other people. So what we can do by thinking out of the box, by thinking bigger, by sharing things, by introducing things that people normally wouldn't have access to, is that by looking at labs and lab construction in a completely different way, we can change that paradigm of education completely. So that's what he said. I say you can teach students with a single piece of equipment and they will do the experiment. With more sets, you could integrate the teaching and the experiment. If you also share the equipment, you can better integrate the teaching, save time, money, and effort. Thank you very much.
Thank you very much, Professor Stephen Week. I call to the stage now Professor Albert Kamp. He was the former director of education at the U Delft Faculty of Aerospace Engineering. Since its launch in 2014, he has been the co-leader of the Dutch 40U Center of Engineering for Education, that experiments and innovates in higher education, engineering education. He has written several influential books and reports on the subject of engineering education with recommendations for development of educational vision and strategy and their implementation in organization and curricula. And he comes to us through challenges to think outside of the box, I guess.
That's the purpose, yes. Good afternoon. My speech is, well, the future of engineering education. Adapting to change, how much, how fast, in what way. And my intention of this presentation is to provoke thought. Because, well, your intention is to benchmark your educational model. And benchmarking, of course, is one thing. But if you want to really develop a vision on engineering education, that is really a very different thing, a different story. And especially for a society that goes faster and faster, and not only goes faster, but also changing faster. And changing the world of our graduates, changing not only how we teach, but also changing what we teach. And you will have to envision, say, all these changes and to make your choices to make a vision for the future of your engineering education. And today my presentation will focus on what to teach. Because what exactly is the purpose of your education? Do you know that? Is it preparing for a future job? Is it developing knowledge? Or is it developing people? Do you know? Do you actually know what the young person must know and must learn to lead a responsible life in this, well, rapidly changing world? Much of what we teach nowadays is actually, well, about how to analyze, how to design and build advanced systems, machine products and processes. And I find it always surprising that what we teach right now is about the same as what I learned in the 70s. Namely, how to understand, analyze, design and engineer advanced systems, machines, processes for the second industrial revolution. Like a Boeing 747, or a space shuttle, or a chemical plant, or a big container vessel powered by immense diesel engines. And of course I understand that, let's say, the fundamentals of engineering haven't changed. But is that their argument to keep on teaching what we have always done? And we seem to forget that the engineering and the research processes in the world, they have really transformed into collaborative efforts of people with different backgrounds and different needs and different expectations. And we seem to forget. And where success not only depends on the expert knowledge, but also on trust and on good relations and on respect and adaptability. And these aspects are getting as important as the mastery of theoretical concept analysis and theories. And why is it then that these personal developments of students is a question mark, actually, in many curricula? So much hidden in curricula, and maybe I missed it. My Portuguese is not that good, but I could not find them on the website in your curriculum. So most of what I will be talking about is on the impact of the changing society and the changing students on higher education and the shift that's going on to more human values and to more human qualities. So, what actually is your understanding of engineering education? For decades, probably also your faculty has been teaching what and how you have always done. And that has definitely proven its value in the 20th century, for sure. But was it under the guise of, well, it's so much easier to teach them for our past than for their future? Or is faculty afraid of losing what they have built up? Does it maybe mean that engineering education is a little bit stuck in a rut while we are living in an age of accelerating change? This can't be true. So change is overwhelming, and people may really feel uncomfortable, anxious, and paralyzed by that. And that's not only to do with, let's say, the recent COVID pandemic or the Ukraine war. No, think about the hyperconnectedness of the world, the infinite access to oceans of data and information, but also the blurring of boundaries between disciplines, between departments, between countries, between hierarchies. Think about the emergence of artificial intelligence, of bioengineering, of quantum computing, and the digitalization of society, the energy transition, the future of clean technologies, next generation materials, and the very high concerns about safety and cybersecurity. And we see in nowadays the world, the fusion of cyber space of data and information with the physical space of the real world, and the beginning of the fusion of engineering sciences with social sciences. And then there's still the risk of the rise of the intelligent machines that soon outperforms engineers in non-routine cognitive tasks. So today's students not only have to learn how to adapt to all these changes, but they also have to shape those changes because it's their future. And it may sound paradoxically, but that's exactly why they need a broader intellectual range in this highly specialized world. Designing solutions for these complex societal challenges involves so many different and contradicting and conflicting perspectives. So a world where human values and qualities are getting more and more important, and the mastery of theoretical knowledge and analysis in a single discipline is not enough and definitely no longer the marker for academic excellence. So how are you going to deal with that? Here you see a kaleidoscopic picture of the digital transformation. And that's actually the world where our graduates, your graduates, will work in. The engineering process is changing into digital engineering. It's a world of capturing and unlocking data to generate virtual models and build data sets for training algorithms. It's a world of crafting designs in a digital environment. It's a world of model-based engineering with immersive technologies to rapidly understand all kinds of and adapt in all kinds of changes across the life cycle of that project. It's also a world of validating designs that keep on learning and modifying themselves even after delivery. And it's a world where data and machine learning are emerging and force us to think more statistically rather than deterministically. It's a world where we can create hundreds, sometimes even thousands of different designs and evaluate them almost instantaneously by computing in the cloud. And we call that optioneering, where we co-design and research in open networks and through digital platforms and collaborative design labs. And that's how the world of engineering is going to look like. And students have to be equipped with these new ways of learning. And that's much more than just learning how to program in Python or 3D CAD programming in SolidWorks, for instance. And is that already in your courses? What about data sciences? Well, I would say let's not talk about data sciences. Data sciences may sound sexy, but by far most of your graduates will never build models for getting machine learning in operation. And that's actually what data scientists do. But every engineer will do data engineering, understanding the value and the validity of data, knowing how to annotate, to clean and shape data, doing large-scale data modeling and work in the cloud. That's what they shall learn. So rather than learning data sciences, it's way more important that the student learns how she can manage her data in a team of, well, systems engineers, nerdy computer scientists, data scientists, and all kinds of artificial intelligence and other users and customers. She has to learn that that's much more important than to model data for machine learning herself. Now, Of course, it's not only the digital and data that is changing engineering, because it's also the business that is changing, the sustainability, the social impact that enter the daily work of the engineer. Cybersecurity, cyber resilience, data privacy, consumer understanding, transparency, trust. It means that performance, functionality and cost are still important, but the other aspects are getting more weight. And where in your courses do you make students aware that the demands of customers and users are changing? Now that brings me to a long list of all kinds of competencies that are getting more and more important every day. And I've put them in alphabetical order because the priority may differ whether you are working in an engineering business or in a scientific institution. But as you can read, many of them are about cognitive, interpersonal and self-leadership skills. And some people call them soft skills. Well, I would say forget that word, because I would say call them durable skills, because students shall not learn them for their exam, but for their life. And they are at least as important as knowledge of engineering fundamentals. But when I scroll through all the study guides of dozens of universities in my university network that I have, I see a big discrepancy between all the thousands of detailed learning outcomes defined for understanding knowledge, analysis and application, and hardly any for these durable skills. So there's work to be done. Isn't it strange that so many programs hesitate or hardly respond to all these changes that are going on in the world? Are they not aware? Do program directors intentionally decide not to think about all these changes? For many decades, universities have assumed that the future is just a linear extension of the present. And actually it is, but just for 5 or maybe 7 years. But developments in society go that fast that actually we can hardly imagine how the world looks like more than 7 years from now. How we live, how we do business, how we travel. So many programs have been following this linear line, emphasizing the how and the when mindset, teaching how we have always done. And it has a focus on rational problem solving, on the mastery of theoretical concepts and theories, analysis and optimization, understanding certainty and developing order, but that's no longer enough. And that means mastering, because young graduates shall also be prepared for the new ways of working. And that means mastering of digital engineering, for instance, and not only problem solving, but also problem definition, and taking initiative and creativity and imagination, and coping with uncertainty, self-confidence, adaptability, risk-taking, learning from failures. That's what I need to be able to work in the future. And of course also interdisciplinary thinking. And I know that's always a delicate topic in a research university to mention interdisciplinarity, because specialists associate interdisciplinarity also with, well, that's too soft for the tough minds. But interdisciplinarity isn't having a bit of this and a bit of that, because it is about learning integrative skills, building synergies between different forms of knowledge and peripheral domains. It's about tacit knowledge, about panoptic perspectives, and about the willingness and the ability to go and to read widely. Maybe you think it's all just a hype. Forget it. I've seen all these changes. Let it go. But I would say your courses have to be prepared for the new ways of working for the students, shouldn't they? And if you're not going to change, you can have an excellent programs, but you may soon be obsolete. Because recruiters, they have a very different wish list than 15, 20 years ago. I often hear, can't they learn this all once they get a job in the industries, when they join the workforce? And they can and they have to. But young graduates need a kickstart nowadays. I read in a recent review by BBC WorkLife among 4 million LinkedIn posts that more than 35%, and in digital industries even up to 60% of the postings for entry-level positions, they asked for years of prior relevant experience. These advertisements read, "We are happy to hire entry-level people as long as they have a broad intellectual range and 2 years of experience." And BBC WorkLife found out that over the past 5 years, job listings for young graduates require 20% more competencies and very different ones than 10 years ago. Like excellent interpersonal communication and collaborative skills, and high responsibilities, and consumer and customer facing roles. And these kinds of more personal and social competencies play a key role in the recruitment and career promotion, to secure employability, to be happy at work, and to get a good salary. And that's also the outcome of another survey made by McKinsey among 18,000 professionals in 15 countries just half a year ago. And in these triangles, you see the top 3 competencies that are needed most for employment, job satisfaction, and a good income. And again, these are merely about human values and qualities like mental flexibility, relationship building, self-awareness, self-management, entrepreneurial thinking, personal goal setting, and self-development. And it's quite shocking, actually, that McKinsey found out that universities are not so effective in teaching these skills. McKinsey even found negative correlations between the level of education and the proficiency levels of students for empathy, self-management, and coping with uncertainty. It's really an interesting report, I can say. And we see the same thing happening in labor. If you go back in history, we see that physical work, of course, is taken over more and more by machines. And the World Economic Forum expects that it will not take long that intelligence machines will also take more and more non-routine cognitive tasks from our engineers, like analysis and optimization and modeling work. So you may ask yourself, what then is left over for our engineers who are currently in our classroom? And that's actually the things that machines cannot simply do, like creativity and imagination, for instance, or transferring knowledge to different contexts, or taking different perspectives, or critical thinking. And although it's not here on this list, I think it's also common sense, because simply I expect that these super intelligence machines which are currently under construction are simply too stupid to have any common sense at all. And we see an important role for emotional labor, like empathy, building relationships and self-leaderships. And it's no surprise that both McKinsey and BBC WorkLife found exactly these things as, well, the key issues for the future graduates. So it's great that you want to benchmark your educational model and that you open your window and let the world flow in and see what's going on in the Netherlands and in Denmark and in the United Kingdom. But don't forget also Singapore and Latin America and Australia, I would say. Because in many emerging leading institutes, scientific discovery slowly drifts toward more human values, where people broaden the range of education in science and technology, disrupt the curricula with more space for interdisciplinary systems thinking, entrepreneurial behavior, self-leadership, and trust and relationship building, and purposefulness. And they put it in new models of education. And once you are benchmarking your education, this could be a good opportunity to think about new models of education, where human values matter more than ever. And these aspects have to get more attention in the learning process of engineers. Not bolted on top of, but integrated in all these disciplinary courses that we shall have anyway. And then, of course, if you then agree that human values matter more than ever, then think how you can teach how to do what intelligence machines cannot. What things cannot be imitated by intelligence machines? As I already mentioned, intelligence machines cannot show empathy, for instance, to customers or realize new ideas in an organization. And they are not so impressive in unquantifiable thinking, or they cannot imagine or synthesize or apply information to different contexts. And they cannot cope with the serendipity of life. So these are the unique values and qualities of the human people, the human engineer. And the higher the proficiency level you can achieve in your curriculum, the higher the quality of your curriculum is, the higher the value of your program outcomes are. So, what does this mean for students? Actually, fortunately, we have also students here in this room. Well, this is Professor Jean Twenge from San Diego, and she made a very interesting longitudinal study over, well, decades. And she says that today's students are much younger than their predecessors. And her findings are that 22-year-old students right now are like 18-year-old baby boomers. And it means that they need more guidance in the classroom and more time to grow up. And probably that is caused by the fact that they are living their life merely online. That's her conclusion. Generation Z students want jobs that matter for society and contribute to the common good, with the United Nations Sustainability Design Goals in mind. And they want to learn what's relevant for their life and career, and therefore need a broader range than just knowledge in a narrow discipline. And they may find it scary, but they have to learn who they are, how they understand the world, what they can expect to gain from their study, and what their aspirations are for the future. But it's good to be aware, and I don't know whether that applies here to Porto, but students in the Western world, they may have different ideas about personal development than people from Eastern countries. In the Western individualistic society, students are mainly motivated by personal interest and self-confidence. And they want to have tailored study path, make build-it-yourself careers, build up distinctive CVs. It's the passion for very personal success that drives them. But for students from collectivistic Eastern countries, this may be very different because they are driven by connections as supportive to others and want to make social contributions and meet expectations. And for them, it's much more the societal impact and the purposefulness of what they are doing that drives them. So if you decide to integrate all these kinds of self-leadership and interconnections between disciplines, etc., think about the differences that you may have between, well, the Western and the Eastern students if you want to make it inclusive. Now, at TU Delft, there are a couple of bachelors, the Bachelors of Maritime Technology and Electrical Engineering, and master programs in robotics and biomedical engineering. They are making currently really serious efforts to implement these human skills into their curricula and add substantial space for social interaction and interconnections between disciplines by giving students more responsibility to themselves and make them the change agents for their own study. And scaffolding by coaching and mentoring and peer groups, and that's exactly what this Generation Z group needs. And for the teaching, of course, this is not an easy thing, because most of you have been selected for your academic excellence, and you are mainly focused to transfer high quality scientific knowledge to your students. But mentoring and tutoring and coaching students in self-leadership, for instance, with emotional and social competencies, that is really a very different thing, where you may have to set individual learning goals that differ for each learner, that cannot be made smart enough, that cannot be detailed in advance, and that cannot be assessed in detail. So probably many of you need to relearn and get used to a different role. A role where you need a different perspective and a broader range and agility. It will take courage to do this. And the question, of course, is, are your teachers ready for that? And I'm not talking to you as only a lecturer, but also for the program directors and for council members or board of examiners and administration. And not to forget, of course, the trainers in the teaching and learning lab. Benchmarking your educational model and developing a vision means you will have to rethink your strategies and portfolio, your assessment models, to integrate digital engineering and your data engineering, and to discuss the data privacy and the cybersecurity issues, and interdisciplinary learning. So there is a lot on the agenda to think about. And then to accommodate the individual study path and how to mentor and coach all these students. You will need courage. And the question you have to ask is, are you willing and capable to teach beyond what you have always done? So September last year, I was in a forum of the European Network for Accreditation of Engineering Education, known for its EURACE accreditation label in Brussels. And in November, I have been updating the CDIO network syllabus. Maybe you know the CDIO, that's a university network of 200 universities that I'm chairing. And the syllabus is such a universal set of competencies and knowledge areas that actually each engineer should know. So if you're going to recalibrate your educational model, this might be an interesting reference for you. And both in the accreditation network and in the CDO network, we were discussing the advances in exactly these topics that I have mentioned: data engineering, digital systems engineering, ethical and sustainable engineering, interdisciplinarity, interconnections between different disciplines and society, and the role of human values and qualities. So the questions and the awareness about these topics is everywhere. Well, I started this talk with the question, do you know what a young person must learn to lead a responsible life in this rapidly changing world? And actually, I want to conclude with 3 questions rather than just a conclusion. If you really want to benchmark your educational model, find out if your program and your organization are agile enough to respond to change. How are you going to adapt to all these changes that I have mentioned? And what choices are you going to make? And what is your position, your personal role in this? And what do you need to make it a success? All I can say is prepare yourself and prepare for change. Be ready to unlearn and relearn and upskill yourself. Thank you very much.
Thank you very much, Professor Alderkamp. I call now Dr. António Bahia Reis to the stage to moderate the questions. Professor, can you perhaps leave a room in the middle for António so that he's in the middle of you? So let me introduce António Bahia Reis. He's a former student of ours, as Professor Faculdade mentioned already. He's a researcher, an educator, and an artist with a bachelor in international relationships and a master in communication and a PhD in digital media from University of Porto with collaboration with Stanford University. He's currently an assistant professor in the Center for Media and Communication of the University of Passau in Germany and founder of the Future Media Collab. And very soon, he can already tell us he's going to be joining Coventry University in the UK to become the course director of their new master's degree in virtual and augmented reality, a theme that has been following in his research career. Thank you very much. And
thank you so much. Good afternoon, everyone. It's good to be back after almost 1 year living in this, my dearest Faculty of Engineering, and for the right reasons to talk about the future of education within this field. And I do believe that we've kicked off with some interesting questions, more questions than answers actually. Some slightly subtlety provocative, I would say, yes, in a good way, I suppose, and some more constructed in a way that we can actually optimize it to the, because there are things that are not necessarily human-driven, that are, inherently logistic, and we have to cope with that as well. I believe the key is actually trying to understand how we can cope with those sometimes, necessary logistic kind of nuances and come up with an all-encompassing kind of an holistic perspective of what can be the future. So let me say beautiful titles for both of them, on being the right size. And with all due respect, Professor Beck, throughout your presentation, I was always keen to know a bit more when you mentioned for the first time interesting and fun, interesting/fun. I was hoping that you could elaborate a little bit more of that. Then you talked about gamification. I was like, wonderful. Let's see how they actually do that. But I do like the idea. It's a wonderful module. It's perfect. Perhaps we can share even like synergies in terms of affecting each other's kind of repertoire, and the idea of short labs. So I perhaps might start with you, Professor Beck. and this idea. So how actually, can you elaborate a little bit more on this idea of using gamification on actually making it interesting and fun? You've got sorted out in terms of the formula, that's for sure.
Yeah.
And we can all learn from that. So how exactly you do that in the field with the students?
There are a lot of ways that you can think about this, but the idea of labs being not fun is when you give students a recipe book. So when you go, look at the rig, write these numbers down, put the numbers into this equation, did you get 3.58? Or even, how did this compare to your, to the theory? That's not fun. It shows people how things work. It allows them to illuminate things, but actually you're not engaging students. So what you have to do is to think about giving them a question, giving them something to solve, stretching things greater. I've got another lab, which I also wrote, where I wanted to teach. Remember, we need learning or it's useful to get learning outcomes from this. So I wanted to teach about gas laws, and particularly because I teach first year thermodynamics, PV equals MRT. Just, you've got a volume of gas, what does it weigh? It's a simple thing to do. So this is probably one of the most boring experiments you could probably ever imagine. But actually, could you make it more fun? And the answer is yes. So what I've got is, I've got a series of balloons, which are filled with different gases, and they're different colors, and you give these to the students, and you write on them what the tiered value of the balloons are, and you say, tell me what the gases are. It's called Name That Gas. And always a good idea, put an exclamation mark after your title, then they know it's fun. So, once again, so they're going round and they're measuring these and they're weighing them and they're thinking about them. So they're learning about Archimedes' principle, they're learning about the gas laws, but actually what they're trying to do in their minds is work out what the gases are. So you're giving them a meta problem. So they get the learning of what you want them to do, but they're traveling along a journey because they want to. And actually seeing the students running around the lab, and also you make less balloons than there are people, so they have to exchange them with each other.
Okay.
And then they can learn these sort of things. So the idea is, can you give the students a sort of test either against themselves or against each other, which they can then try to do well at. And if they do badly, once again, you can get them to reflect on how they could do better. So a lot of these things are thinking about what the student experience is, what the student journey is, what the student engagement is, rather than do they know PV equals MRT?
Okay, wonderful. It does make sense. And it was curious that as I was kind of, letting information sink in from the two. Yes? Sorry. Oh, questions from the audience, right? Oh, I'm sorry. I was trained as an actor. I've got a self-inflated ego. I'm so terribly sorry.
The afters were last night. You missed it.
I missed the sweets. I'm like a child. They give me dessert. I have a sugar rush. Does anyone in the distinguished audience would like to ask a question to our distinguished guests? Of course, please.
It's relative to the presentation from Professor Adolf-Kamp. Your provocative questions are: can we adapt fast enough, and or can we adapt to the society? And my question is, very often we try to adapt, but then you have the accreditation agency that requires 2 years process, and sometimes it's a fashion or a trend, and when everybody wants to do some kind of new master program, but when the first students are getting out of the program, probably the trend is no longer there. And my question is, can we adapt fast enough and or not? And one thing that I've been dealing with is micro-credentials versus traditional education. Do you think that a micro-credential system where people can, let's say, build their education on small quanta makes any sense, and is the society ready for that?
That's a personal opinion for me. I think, let's say, a complete course as it's a personal opinion, but I think that a complete, let's say, curriculum based on micro-credentials, I doubt how to make that coherent and valid, although never say never. But I have no doubt that more and more students will, well, and that's already ongoing, at least in Delft I've seen, that people get, let's say, courses that they followed online and come with their micro-credentials to the Board of Examiners and say, hey, this is course and I want to have it counted for in my curriculum. So as a substitute of an existing part in your own curriculum, it is simply already there. Maybe not in your program, I don't know, but in Delft, it's simply there. So, and it is a matter of how far do you want to go? Do you want to be able to substitute 10% of all the courses by micro-credentials or courses that are followed somewhere else? Or 20%? Or 50%? I don't know, that's something to think about. But there is no doubt it will come into your institution.
Any more questions? Commentaries? Yes.
Thank you very much for these interesting presentations. Of course that both presentations have dealt with the how. How can we deploy a curriculum? How can we achieve set of competencies for engineers? Although different hows. One is more logistics, the other one is more related also with soft skills, let's call like that should go and be part of the curriculum development. And on that how, I'd like to make a straight, direct question about your personal opinion. Because this is many times an issue of debate. Can we teach soft skills in the sense of having a course, formal course, with the basics of soft skills? Or soft skills is something that you can only acquire by practice, by doing the job or doing the courses, in teamwork, whatever. And this is something also very important because many people think that only by doing you can learn soft skills, but then they don't pay any attention about what's going on in their courses, in the teamwork and whatever. These two aspects I would like to have some opinion, personal opinion, of course. Thank you.
Well, first of all, I think, yes, you can definitely, for sure, let's say, teach or in any case, nurture soft skills. Yeah? It's not only a matter of teaching, because you cannot teach creativity or you cannot teach leadership, but you have to nurture it, to develop it. And that's why I said you do not have to bolt it on top of your existing courses, but you have to integrate it. So once you have a project, for instance, that is currently has its objective as well, learn how to, well, find out, let's say, the gas volume of a balloon, for instance. You can add there elements of, well, teamwork or presentation or writing skills or whatever. And I think that's how you have to do it. And yes, it takes a long way because many teachers, it is not their expertise. I'm pretty sure I've seen that as well in Delft. I mean, they say, well, I'm expert in thermodynamics and I don't know anything about ethics. And we ask them now to insert ethics into their thermodynamics course. And that takes 5 years before that mindset is over. But yes, you can do it, but it takes time and energy.
Also, a lot of these things can be done globally. I mean, I remember when you came to visit us, we told you a little bit about our engineering activity weeks that we put on for all of our students across the whole faculty. And some of this incorporates a lot of these professional softer skills, or at least introduces them to them. So actually, in a way, you don't need to turn your thermodynamics lecturer into an ethics expert, though of course we all are. But you can actually not subcontract that out, but you can get those done more globally, but get them implemented locally. So the skills that people have introduced on these bits, you can then get reinforced as the course goes along. Something interesting we've discovered this year is that the students are very bad at working in groups, the second and third years, because over the last year with COVID, we've taught them to either work alone, because you can only have one person per set of equipment for safety reasons. So suddenly you're expecting them to be able to work in groups, and they don't. They fracture into ones and twos because that's how they've been taught. So a lot of these things you can program through as you go through, but they don't happen by accident. You can introduce them and then reinforce them. So what you were saying is correct, that they want to be integrated, but actually they need to be introduced and then practiced as you go through.
Yes. First row.
Thank you for the presentations. Just one quick question about the spaces, the classrooms, the laboratories. Professor Beck, you talk about the facilities, the modular structures, modular classrooms. Considering the future of engineering education, what do you think about the amphitheaters, the big lecture theaters? Should we think on that solutions? Should we think about different way of teaching, learning? What's your opinion about it?
Good. So even before the COVID struck, I was already moving more and more of my lecture course online, because actually the idea of me going through those equations one more year just filled me with horror. So actually a lot of this learning of sort of the basics, the equations, how to use them, the examples even, you can put online. And it's much better. Students can go through them at double speed, which a lot do, or go through them at half speed, do them at 3 in the morning, whatever. So a lot of what we think of as the way we deliver lectures, I think has been supplanted by electronic delivery, and the way I deliver my course is I give a short lecture online and then a quiz, and when the students get the quiz right, it delivers the next bit. So I can give them their feedback as they're getting through. So then why don't we use the lecture for something fun? Why don't we use it to inspire the students, to show them why we love our subject, more about it, enrichment, enthusiasm, maybe not even to do particularly with the course. So what you can then do is take away the workaday and make the lecture an event. So you need a lot less lecture spaces, but actually each of those ones you put on wants to be a real experience and very high quality. So can we use those to give something of ourselves to the students and say why we're motivated by our subject, what the context is and the rest of it. So you may want a lot less workspaces, but you want to make sure they are high quality and they're used by everyone. So on the other hand, if I'm putting my lectures online, what am I doing with myself? I'm using this in the classic blended manner. I'm using that time saved to talk to the students. I'm putting on more problem classes, more tutorials, more enrichment. And that requires a different sort of space. That tends to require, like you have in Delft, I know a lot of, big flat spaces where students can walk around, where staff and students can interact with each other. You might want smart workstations. So actually, when you move away from the lecture theatre, you then start getting a lot more possibilities of actually student engagement and, once again, them enjoying themselves, talking to people and the rest of it. So I think as you move away from boring the students by going through 30-year-old slides and move towards interacting with them and infusing them, that's where the future lies. And I think we need many less lecture theatres and many more flat spaces for that sort of purpose. So, I think if you're looking forward, that's what we want to do. But of course, it's very easy. You could turn this into a flat space with a couple of sledgehammers and a couple of weekends. So, you can actually adapt spaces as well.
Thank you very much.
In Delft, indeed, we have transformed, let's say, or auditoriums like this by making it flexible areas where you can turn tables and turn the chairs so that you can make small groups of 6 or 8 people. So it is agility or flexibility that is the key word here.
Okay. I think we're right on time. We can compensate for the extra 5 minutes we lost. Let's keep in mind some things. Perhaps we can talk about this later, some questions that still stay in the Ethereum, let's put it that way, which is like, and very concerned about that, which is the resistance from educators, long-time educators, to actually relearn. I remember doing a few years ago a workshop on public speaking to academics, senior academics, and I had a lot of resistance from them. How dare this young mind come here to tell me how do I teach, and I was actually very humble enough to actually give them some new insights and obviously exchange energy. So in thinking about spaces, thinking about structure, this is very perpendicular. How can we sort of think about in infrastructures? It's kind of the mindset you were. But let's leave it for the coffee break perhaps, and let's keep on track. Okay, thank you so much once again, and we'll keep with the program. Thank you.
Thank you very much for all. Maybe you can go back to the front row, yeah. So now I call to the stage Professor John Mitchell from the University College London. He's a professor of communication systems engineering, and he's currently the vice dean for education in the UCL Faculty Engineering of Sciences. His research is focused on optical and wireless access systems to support mobile front-back all systems, and since between 2012 and 2016, he was on secondment to the UCL Engineering Science Faculty Office, where he led the relevant introduction to the Integrated Engineering Program. The team that led this major revision of the curriculum across the engineering faculty has recently been awarded the HEA Collaborative Award for Teaching Excellence. Thank you very much for coming us.
Oh, thank you, Joe Pedro. Good afternoon, and thank you again for inviting me to come and speak here today. I'll start by saying a little bit, sort of a comparison of UCL, and then say a little bit about why we went about changing our curriculum and explain some of the things we did to make those changes. So UCL is a research-intensive university, one of the oldest in England, where at the time, to go to Oxford or Cambridge as the two universities, you needed to be a member of the Church of England, you needed to be a man, and you needed to be rich. We said about at least the first two of those. It's debatable whether we've solved the third yet in the UK. And the size of our faculty is roughly the same, I think, to that here. We were about 3,500 undergraduate students, about just over 2,000 postgraduate taught, and about 1,000 postgraduate research students, PhD students. So in 2012, as was mentioned, our dean went away to the Global Deans Convention, I think in Chicago, and saw a lot of things going on with problem-based learning and CDIO and all sorts. And as deans occasionally do, they get very excited by such things, and came back and Sunday afternoon sent out an email suggesting that we change our curriculum and introduce problem-based learning. And about 6 months later, I took up the challenge of, what does that actually mean? What does it mean to change a traditional curriculum that by the usual metrics we apply to universities was doing very well? It was recruiting lots of students, and virtually all of them were graduating. That was the traditional metric we used of our students. Appropriate number got good degrees, and that was also good. But why would we want to change, and what would we want to change? So one of the first things we did was look at, well, what do we actually mean by being an engineer? What is it that we are attempting to do? And after a bit of time, some colleagues of mine came up with this statement, which is a slight modernisation of the old Treadgold that was the foundation of the Institute of Civil Engineers in a coffee shop on the Strand in the 1860s. And so we talk about the art and practice of changing the physical world for the use and benefit of all. So I'm just going to unpack that a little bit, because this is quite fundamental to the way we wanted to think about the engineering education we were given. We wanted to talk about art. We wanted to talk about engineering being a creative subject, that engineers create things. Many of our students had this concept that engineering was just about solving equations. And while mathematics is necessary for being an engineer, it is certainly, in my opinion, not sufficient. We actually wanted students who could be creative, could come up with innovative ideas, and wanted to promote that from the beginning in our degrees. And that is practice, it is not just theory. And that right from the beginning of our degrees, thinking about how the practical elements, some of the things that Stephen was talking about, how we go from labs to projects, and how we ensure that the practical side of engineering is interwoven with that theory, would be fundamental of the type of curriculum we wanted to create. We also wanted to emphasise that engineering doesn't happen in a vacuum. The idea that we are creating things or coming up or developing new knowledge is fundamental to the physical world. What we are doing is influencing the physical world, and in that physical world there are people. And understanding the social, the economic, the sustainability issues, the ethical issues of what we are as engineers doing is absolutely vital to being a good engineer. And so we now often talk about engineering solutions being feasible, being viable, and being desirable. And if I look back at our old curriculum, we spend a lot of time in the feasible. Does it work? Can I make this thing actually work? Where we spent less time certainly was in the viable, which is in part the economics of it, and certainly very little in the desirable. How do we understand the users? How do we understand what the technology is going to do for people, with people, and in the environments that we're going to deploy it? So that was very fundamental to how we wanted to change. And we had to think about a number of competing demands we had on why we wanted to change. One of the big demands was inclusivity and diversity, wanting to grow the cohort of engineers that we have. Now in engineering, obviously gender is a key issue. If you were watching this live stream and look at the panel here, would you not be asking yourself, why are there no women in engineering? Why are we like this? Why is this happening that we have a white male panel here today? We also want to think about diversity more broadly. Why are we just bringing in students who are good at equations, good at maths? Should we be looking for a much broader range of students coming and seeing engineering as a career that they want to engage with? And the students are asking for this. Talking to our students, talking to those coming in, I'm always shocked about how socially aware and how engaged with engineering being a potential force for positive good that our students talk about. It's certainly something I don't really recognise from my day as a student, but very often, unprompted, our students will talk about the impact that they hope they are going to be able to make in their engineering careers. But of course, there are also raised questions of employability. I think our students are more attuned with the idea that it's a degree as a pathway to a job than they ever were before, and are aware that they are not going to go into a career for life, as many of my generation and generations past have gone into working for the same company for the majority of their time. They will move between certainly companies, but also between sectors, between areas as they go through their careers. And the education we provide must provide and enable that. As well as, certainly in the UK, and I'm sure many countries are the same, there has been an absolute procession of reports suggesting that the graduates that universities are producing are not quite right for industry or not fulfilling all the demands that industry has. Now, some of those demands, in my opinion, are unreasonable, but many of them are actually asking for engineers that are not just technically good, but have great communication skills, can work across different disciplines, can one day be talking in very technical meetings and in another be talking with customers and with clients. And this is the sort of roles that our engineers are going to go to. They're not necessarily just going to be technical specialists. They're going to be the integrators. They're going to be the sorts of emotional intelligence that are needed from our students is going to be huge. So what might a curriculum like this look like? Well, we want something that has problem and project-based learning. We think that's a core to teaching, vehicle to teaching some of those skills, with more group assessment, group learning, be authentic, and authentic's an interesting word here. In fact, actually, whether it's realistically authentic, as in that really happens, or the students perceive it as authentic is actually quite important. And it's probably more important that the students perceive it as authentic. And being backed up by research was one key thing we wanted to do. So with that in mind, in 2014, we launched what we call the Integrated Engineering Programme. And what we wanted to do was show how the disciplines integrate, how they work together, how we developed an inclusive curriculum from the start so that all of those that take part are not adapted to, but actually have a place within the curriculum. Authentic, centred on design and professional practice, so the question about the professional skills, the soft skills, we believe you can help people to learn them, teach them if you will, but you also must alongside give them a chance to practice it. And actually those two come hand in hand. And quite often we've done one and not the other, or you've either put people in teams and expect them to learn teamwork, or we've taught them teamwork and they've not had the opportunity to practice it. Actually the two must happen in tandem. And we decided to do this across all our degrees. We took an opinion early on that if we really believed this was the way to teach, we should change all our degree programs, which is interesting. So just to give you a picture of what it was like and what we changed. This would be a fairly usual picture of what our degrees look like. They were individual, there was very little crossover between them, very little connection. Silos, if you will. Daniel Hastings from MIT called them cylinders of excellence, which I prefer, but certainly silos. And this used to be in colour, but it turned grey once, and I quite like it grey, so I've kept it ever since. The idea of the IEP was not to entirely disrupt this. You know, UCL is 500 members of academic staff teaching probably close to 800 different modules, probably about 300 in the undergraduate in different disciplines. That's a lot to change. But what we wanted to do was disrupt the pattern and take away the centre of gravity from these individual blocks of knowledge in these silos and try and put a framework on that showed the connections and change the emphasis from the acquisition of knowledge in modules to the design thread. So we have a challenges module. So this is, last year it was 1,038 students taking part in projects across the different disciplines, working together with students from other departments on integrated projects that start from the first Monday afternoon of the first day of term of the first year that they join us. Alongside that was the professional skills, and so that's where they can practice the skills. This is the point where they, in workshops, work through those skills. They understand about teamwork, about ethics, sustainability, critical thinking. They get a chance to experiment in the small before they go into these slightly larger projects. We had a thread of mathematics, so this is the one subject where we brought all our students together. So in the early days of this project, a lot of people said, well, we could teach all 1,000 students thermodynamics together, or we could teach all 1,000 students programming together, or whatever. As it turned out, when we started talking, although the syllabus of thermodynamics looked similar, the way chemical engineers viewed it was different to the way mechanical engineers viewed it. And actually the value of putting students together in that common language didn't seem quite so strong. Where we felt that actually the students came together and where real engineers come together is over working together on projects. The one exception to this was the maths, but it's the challenges where the integrated part comes together of the students working together. And then mostly our students work in disciplines, but all our departments follow this pattern of the scenarios. And so a scenario is where we stop all lectures for 1 week. This happens 4 times for all the students a year. And for that 1 week, they take on a project. We have had some interdisciplinary ones, but most are individual to the departments. And they focus on a design project that is designed to draw out the learning that they've been doing in the previous weeks and challenge them to do something with that learning. We also introduced minors. We saw that students were... perhaps we didn't really have a coherent set of options for our students. And so here there are 22 minors, but they are a coherent set of modules that go across the second and third years. So students might pick something in environmental engineering, in renewable energy, in something outside their discipline, entrepreneurship, a foreign language, finance, but they sign up for 3 modules across those years and do those interdisciplinary minors there. And I'll also mention a project called How to Change the World, which was our capstone. And one thing we're now trying to follow up with is then the interdisciplinary capstones that follow from this. So I'll give a few examples of the types of things that this looks like. And again, we're now coming up to 10 years since the start of the project, 8 years since the first students coming in. Some of these gone through a lot of refinement over the course of this, and I think this course particularly is one where the maths module, we tried to go to a large class model, and in the start we were in big lecture theatres, and then smaller disciplinary workshops. And now we've ended up with a very sort of case study based approach where we have fundamentals, topics and the core modelling. So to give you an example, this is from one of the weeks where actually I think the topic here is complex numbers, but we're basing it around, actually this is a design that a student of ours came up with many years ago around a microphone. And so it's always placed in a real example. A very complex, a very context-specific mathematical activity. So there are some fundamentals, there are some that would look like an average maths course, but there then is the contextual-based and the idea that for each of these, a small part of it is that the students are building a mathematical model of it. So from a situation where maths was taught by the maths department and it seemed quite abstract, now the aim of every piece of maths is that it is used to build a model of something in the real world to help you understand what is going on for your engineering project. So this is another way of looking at what this program now looks like. I always wind up my colleague who drew this that this is a poor engineering diagram because it's not to scale, because the discipline-specific technical stuff is 70–75% of what's still there. And this in the main is undisrupted. This is often still lectures. Some have flipped, some have gone to different active learning techniques, but we didn't disrupt that much of this. And pragmatically, that was very important, that we didn't want to force someone to teach in a mode that they didn't want, and it's perfectly acceptable that Professor X, who has taught this subject that way for 35 years, can continue teaching that way in this model. But the colleagues who want to join this thread of design have joined in number and are now leading this thread of the projects. So by the time the students come to the end, they have, or the end of the second year, they've got 9 projects of different scales, different complexities, with different styles of teams right the way through. And the emphasis is really now on this as the thread, and that these are things that are supporting the skills, the design classes, the maths, the discipline specific, are supporting this thread of projects, rather than it being somewhat the other way around. So the first challenges module that our students take, the biochemicals, biomedicals, chemicals, look at producing a bioreactor. The civils and mechanicals look at how you would supply power and water to a facility like this. The electrical engineers, computer scientists look at the control systems that are developed for it. And together they're working as a team to deliver elements, just perhaps as consulting engineers might do, where you have your own sub-project within a much broader project. Again, to Stephen's conversation, a lot of our scenarios are quite gamified in that there's a challenge at the end, there's an outcome. This is one of the IMEC challenges. But others are linked to the more industrial need, and they are projects where the ultimate design is not necessarily that all students succeed in. So in an ideal scenario, about half the students would succeed, others may not come to a full outcome. But actually, we're very much looking to value the process of the design. Actually, the outcome is not so much of the important thing for us. And the final project is at the end of the second year. All our second year students. I need to update this. This is going to be nearly 1,000 this year, or just over 1,000 this year, with a number of partners, mostly charities, non-governmental organisations, take part in this How to Change the World, based around sustainable development goals, usually one from a developed country and one from developing. So we had The clean water and sanitation, we had sanitation in a Jordanian refugee camp with an NGO from there. We also had pollution in the River Thames. Different teams taking on this different challenge. And the idea here is that these are what we term wicked problems. We don't define the problem brief. Actually, the first stage of the project over the first 2 or 3 days is for the students to think about the expertise they have, the broader problem in that context, and to define their own brief on how they think their expertise can actually apply to this particular model. If I've got a minute, I would say How to Change the World was a working title. We have lanyards with Change the World as the motto of our faculty on it. And my colleague, who was Kennedy Business School in Harvard educated, came up with How to Change the World, a very positive, and I hated it. Absolutely hated this title for a very long time. It's a bit too out there for me. Maybe that's my English reserve that comes from that. But there are 2 things that I've actually grown to love it. One is a message, and a message to students that, some have said, oh, it feels a bit missionary that you want to go out there and force your world on others. But actually the story is subtly different, and it's trying to say to our students that engineers, management scientists, computer scientists, whatever it is in these fields that cover our faculty, will change the world. Whatever you do, if you invent a device, invent a new process, a new management system, particularly develop a new app. And strangely, the computer scientists are often students who we struggle to get this message over to, and yet, Facebook has had more influence on the Western world than anything over the past 10 years. You are changing the world. Whether you like it or not, this is the influence an engineer has. So you better understand that world that you are changing. And also the students tell us if they write it on their CV, everyone asks them about it when they go for a job interview. And they get to explain that they've taken on a wicked problem, that they've had to work in a team with people they've never met before from different disciplines. They've had to think about the social context of things. And a lot of our students come back and say, I went for a job interview and I just talked about this for 25 minutes and they loved it. These are things that are actually key to ensuring not only that you do the right things, but that students realise that you are developing these skills within them. So I'll just leave this as a sort of final sort of summary of some of the things that we've developed in the programme. It's got a lot of moving parts, and happy to talk about some of the practicalities of doing this. Doing anything trying to get 8 departments to work together with 1,000 students is not simple. There's some quite intricate things to make it work together. But certainly my experience is that it's very worthwhile, and students do really engage with some of the processes that you can put in place with this. And while being still a pragmatic model to keep a lot of the things that are there and that are fundamental to what you do, but to change an emphasis to give this other idea to students. Thank you very much.
Thank you very much. Thank you very much, Professor John Mitchell, for the lovely presentation and the challenge you taught us. I call now to the stage Professor Ewan Lindsay from the University of Aalborg. He has a background in mechatronic engineering and completed his PhD in engineering education. And during his academic career, he has held several senior roles at Curtin University as Dean of the School of Engineering and Technology at Central Queensland University, before joining Charles Sturt University, where he promoted a also very thought-provoking, out-of-the-box program. Ewan believes most challenges facing society can be solved by engineers. Thank you very much. And he has recently started a new challenge at Aalborg University for the last couple of weeks, where his immense experience and passion for engineering will certainly contribute to improve even more the Aalborg model. Thank you very much for coming.
Good afternoon, everybody. How are we all doing? Yeah, okay. I've gone 1-2 slides too far. So Aalborg University was established in 1974 with a problem-based learning approach. That has been who we have been forever. It's our core strength, and it's part of what attracted me to join the institution 3 months ago. So while I am new to Aalborg as an insider, I've been stealing their ideas for a very long time. I'll put it in context to start with. We are based up in the northern part of Denmark, in Aalborg. We also have a campus in the capital in Copenhagen, and we have a campus in Esbjerg that used to be a separate institution. Across those 3 institutions, we have somewhere in the order of 20,000 students. We are the primary university in our part of the world, so there are very strong links to industry and to the community. But what we are doing at scale. I'm going to focus particularly on the engineering side of things, but the underlying problem-based learning ethos is universal for us. It's not just small classes in a couple of places. It is the core of an institution of 20,000 students. And the basic principle behind it is that students learn from doing problems. They don't learn by talking at them, they learn by doing. And so by starting with the problem, and this is the way you learn in any other part of your life except formal higher education. Okay, if you have a problem, you realise you have a problem, you then figure out how to learn it. So they are always working in groups, because practice is a group event. Nobody gets to work alone on an island, not talking to anybody else. They have an academic supervisor who guides them through the process, so they're always being mentored. Learning is a mentored process. You want to make sure there are those feedback, the example, the provision of role models so that they can see someone that they want to be like as a professional when they get older. They are required to document their work in a project report. In engineering, we often require prototypes. So it's not enough to just say, oh, it would look like this. We expect them to show us one. Now, that doesn't mean that a first-year class or first-year students are going to give you a model that you could actually commercialise and sell, but it requires them to have that jeopardy, that consequence of knowing you're going to have to show this off at the end of the semester. And you'll be judged not just on the report you put in, but how you're able to explain what you've done. And so there is a sort of viva kind of defence element to it. The curriculum itself, half of the ECTS are devoted to these projects. So in every semester they are with us, they have a project. Semester 1, day 1, there's a project. Final semester, there's a project. Everywhere in between, there is a project. And that gives us an opportunity to provide a whole range of different projects as we go along. The other half of the curriculum are specific courses, 5 ECTS each, and that is where you get the traditional delivery. I'll use the word delivery rather than teaching because I've got some biases. But that's where we get the delivery of the traditional maths, the fluid mechanics, those kind of technical content areas are delivered in parallel. But for every semester, they have a project. This is how we work. And so essentially, you rebalance the contact hours. It's not a reduction in contact hours if you consider it contact with the learning. They don't spend as much time in rooms like this being contacted remotely not remotely, but it is very remote up the back. How you doing up there? We don't talk at them to the same amount. What we do is we've moved from that individual assignment type work you see in a traditional program to teamwork. And that means we have a much smaller yellow part. Now I can tell you, you can do without the yellow part entirely. But that's outside the scope of this Aalborg talk. It would be my other CSU engineering talk. You have to substitute in another colour in small pieces, but it is possible to delete lectures entirely from a curriculum. We haven't done that, but we use them to support the projects that they do. And they are constantly working in projects. They're in teams. We give every team a home. Now that's very easy to say, but it has stunning consequences for the way you lay out your university. Because you've got to find in groups of they start about 6 or 7 at the first year, they get a little bit smaller down to 4 or 5 at the later years, but every single one of those teams has a space on one of our campuses that they call home. They can leave their bags there, they can leave their kettle there, they can work there in groups, they have their project plan on the wall telling them when everything is due and how they're going to manage amongst themselves. That's where they default to, even if they're studying the thermodynamics, that's where you'll find them. And it's great if, for instance, you're going to Portugal, you need to take a photo of a student team, you know where to find one. They're over there in the student spaces. You can wander in. Excuse me, guys. Put it in your slides, it's all good. They have a home. And this is a huge investment in the physical spaces, but what it means is that they're able to practice. They're able to work like engineers. They're able to have that home environment. They can lay things out. They've always got somewhere that they know they can go to. They know that their stuff will still be there. They can put the post-it notes up. This is the life of an Aalborg student. They are constantly working in projects. But it's not enough to just put them in projects and assume that that will work. You have to constantly move back and forwards from the abstract to the real. And those of you who love your learning theories will see a bit of the Kolb learning cycle here. But it is important that we go physical project, this is what you're doing, give us a product at the end. But we also have to make sure that they are understanding what it is that they're actually doing. The competencies involved in working in projects, working in teams, and also knowing what they're actually doing. And so we have identified, and I do apologise, there are a lot of words on this slide, which I'm not going to apologise. There are problem-orientated competencies. There are competencies. We had a question earlier of, can you teach team skills and professional skills? Yes, you can, and yes, you must. It's not enough to just assume that because they've been in a team, they will have gotten it, okay? We've all got a lot of colleagues who don't have 10 years experience. They have 1 year's experience 10 years in a row, all right, where they learn nothing from it. No? All right, maybe you don't have those colleagues. Sorry, the jokes aren't going to get any better. I do apologise. So just bring your standards down and work with me. There are specific skills you need to be able to work in a problem environment. Problems don't solve themselves. You need to be able to identify them. You need to be able to work through the problem types. And I was very pleased to see the Sinefin framework sneaking into Albert's presentation earlier. There's ethics, there's sustainability. These are not things that just suddenly happen. You've got to teach them about utilitarian ethics. There are interpersonal skills that are required to work in a team. You've got to teach them these skills. You've got to evaluate them. There are structural competencies about how do you actually make sure that things happen on time. Okay? The teams that start at the deadline and work backwards of what needs to be done now do very much better than the teams that start now and go, oh, what should we do next? And on top of it all, you've actually got to give them the metacognitive competencies to know what they know and to know what they're learning. So it's not that you put them in groups and by an amazing amount of luck, they suddenly become good at group projects. Okay? You put them in teams to give them an example opportunity to learn all of these things. And even more importantly, we explicitly teach it. So one of those 5 ECTS subjects that you will remember from the structure of the program in the first semester is about these competencies. So not only is there that PBL project, there is a subject where we explicitly get into these things. We explicitly say this is what it is to work in a problem-based learning environment. This is what it is to work on an engineering problem. This is what it is to work in a team. And so we are front-loading not just the technical content and not just the problem, but also the competencies that you need to develop to be able to work in those problems. And then we come back and we run workshops embedded in the later years. And so each individual course director will work out which of those particular competencies they want us to emphasise. They reach out to the UCPBL. And so we go into the 4th semester, the 6th semester and so on and say, right, let's get in depth on this particular competency that ties to where you are on your student journey and what you need in the balance of your subject. And then at the end, they are required to produce a PBL competence profile. Hi, I'm Ewan. I'm very good at problem definition. I'm very good at ethics and sustainability. I'm not good at working in teams if I have to work with people who don't share my absolute drive to excel. That's not what that says. That's how I would do it. Every student is able to produce one of these statements. They know what they're good at. One, they have a vocabulary about these are the skills that you need. So they know what it is they're supposed to be able to do, and they know whether or not they're good at it because they have the metacognitive and the reflection skills to do it. And then they put it on a piece of paper and we evaluate them on it. And then they attach it to their CV when they apply for jobs and they get hired in favour to the graduates of other Danish institutions. Because employers don't just have a grade point average to understand whether an Aalborg graduate will suit them. They have this statement of competencies of this is what I'm good at, this is what I need to work on, these are the capabilities I have. I know how I will fit in your teams because teams aren't a mystery to me. We've been very deliberate about it. And so it's not enough to just assume they'll learn it somehow by osmosis by being in a lot of teams. You've got to explicitly scaffold and develop it and then finish with a statement where they have to reflect on the way in which they've done it. Still with me? Excellent. So what I want to do now is to talk about some of the ways we implement the problem-based learning, how we actually do the PBL projects. We did a study within our centre at the UCPBL, and the overwhelming majority of problem-based learning implementations are a single subject, a single project for a single semester. All right? The course is the project is the course, it exists now, and then at the end of the semester, it's gone, never to be seen again. And that's one model of doing it, and to be fair, a lot of what we do is that. But if you look around the world, that's the dominant model. That the only reason this project exists is for this subject, and this subject is just that project. But you need variety in your life. I don't want to push my colleague under the bus, but I did have a colleague who insisted that I keep the ladybird slide. You know, it makes the point about variety. There's lots of different types of ladybirds. Yeah. They're all ladybugs. They all look slightly different. There's no one correct way to do problem-based learning. Okay, and as you're benchmarking, don't believe anybody who's only trying to sell you the one type, all right? There's lots of different varieties. And you get what you want is variety in the kinds of problems that you have and varieties in the kind of projects that you do. Okay? Now, the luxury of having 10 semesters with a project in every semester is you can have variety. And in fact, what we do is we give them a catalogue of projects and say, these are the kind of projects that would be appropriate for a 4th semester mechanical engineer. You and your team should choose one quickly, because we've only got a semester, so get into it. And so you want that balance of the open-ended, ill-structured, complicated and chaotic problems, as well as the narrow and well-defined projects. You want projects that are very much give us a definite answer, and projects that are very much the open-ended ingenuity where the name of our profession comes from. You also want to be able to deal with teacher-driven projects, where we say this will make a great project, as well as the student whose family owns a farm and has a really cool technical challenge they want solved for the farm, and they say, would this be a good enough project? And we say, yeah, or no, we do evaluate it, but the students do have the possibility to bring their own project. And so we want to have that variation in problems that we face. We also want to have the variation in projects. We want some very specific disciplinary projects that are so hardcore about the fluid mechanics. We also want to have interdisciplinary projects. We also want to have what we call mega projects. What's a mega project, I hear you ask in your mind, because you're not comfortable shouting it out loud. But this is something that we wanted to move into, are moving into. As a way of breaking that, it's just about the one semester. So the idea behind a mega project is that it's something that is too big for one subject, it is too big for 1 year, and it is too big for one discipline. It is mega. I mean, in Portugal, I presume you guys abuse the word mega, same as we do everywhere else in the world. Yep. Excellent. And so the idea is that this is a project that is bigger than just today. It's bigger than just this semester. And the first two that we chose were simplifying sustainable living and the circular region. Again, linking back to our sense of place in Nord-Jutland. But you'll see that these tie very much to the UN Sustainable Development Goals. And they are something that is absolutely critical to us at Aalborg. You go into the tea room and they're there on the wall. It was a bit, whoa, hang on, that's colourful. And okay, it is something that we live and breathe. And so what we do with the mega projects, the idea is that these are projects that are too big for one set of students to solve. They need to interact in a broad, cross-disciplinary way. And these are problems that will also be there next semester. That sense of inheritance of people, students next year will have to use the decisions that you make this year. Because interdependence in your projects, when students know that their outputs are going to be somebody else's inputs, it really changes the way they go about engaging with the project. Now in industry, that's how it works. You would not be making the output if somebody didn't want it as an input. But in class, so often, the only thing I'm doing is so that I can get those marks, the I want the marks phenomenon that Stephen mentioned earlier. And so what we're trying to do here is to say, well, these are wicked problems, they are huge problems, and maybe you can make a meaningful contribution, but at least you should try. And it's critically important that you as engineers realise that there are non-engineers out there that can contribute to these solutions. Okay, I think engineers can solve many of the problems. Some of them are because we made them, okay? But these problems and these solutions affect people. You need to understand how non-engineers will view them, because most of the people in the world affected by these solutions will be non-engineers. Now, here in the cone of silence, don't tell anyone. This is a little bit tricky with the rollout, because we're finding that the breadth of the broad interdisciplinary challenge is a challenge for us. It's awesome to put that context in. It's awesome to explain the value to it, and the students appreciate that. But then you've got to scope it down to something 14 weeks from now that we can tangibly deliver. And that is very challenging for us in the first instance. We continue to work on it and we continue to improve it, but part of my plan today was not to just come here to show you the things we've been doing well for 40 years, but rather to show you the areas that we're moving forward in the future. And the value of a persistent project that carries on, that requires you to respect other ways of knowing, is absolutely worth the challenges that we're working through. So we continue to work on this. The other one that I want to show you is a more narrow interdisciplinary project, which we call Leading. And this occurs in the second semester of first year, where that catalogue of projects that they can choose from includes 3 projects: a vertical wind turbine, a Stirling engine, and a sustainable electric vehicle. Now, the difference about these 3 projects is that more than one team can choose them. And so they work in a team of teams approach. So the 9 teams working on the vertical windmill are all working on a different part of the same windmill. And it's awesome, because they depend on each other. And I can't go any further until they've told us how big the wind blades are going to be. And they can't go any further until the people who've designed the shaft have told us how thick that's going to be. And so that interdependence of, when I make decisions in my team, it affects my team, but my team's decisions affect the rest of the windmill. And that sense of, we have to be able to work between teams to understand how this is all going to work. Because if you make the car heavier, it changes how hard the brakes have to work, it changes how hard the motor has to work, which changes how big the battery is, which means you need a heavier battery, right? Which means you need a bigger motor to drive it, which means you need a bigger battery, which makes it heavier, which means you need a bigger motor. And eventually they work their way through it. And we found that the teams that engage in this have a much clearer sense of practice. They're getting that authenticity that John alluded to, because they realise, as they always do when they've made a mistake, that mistake not only has to be fixed in their part of the project, it has to propagate then to all the other teams. And whoever it is that they've chosen from their team to go to the steering committee meetings with a member from each of the other teams has to explain how sorry they are they missed a minus sign on the pitching of the windmill blades, and now we need to redesign other components. Perfectly normal part of practice, but something that isn't present in those other subject equals the course equals the semester projects. And so by not making it quite so far, we find engineers are much more comfortable working with other types of engineers than they are working with non-engineers. And you need to do both, but we're finding that scaffolding them a little bit is working very well. The other thing is that these projects are partially persistent. And so this year's windmill has been inspired by last year's windmill. They got to see the prototype, but they are not rebuilding on top of it. So they are not taking last year's design and expanding it, but they can see what was good enough last year, and now they understand that they need to expand. Moving forwards into the future and where we're headed, the first big one is digitisation. And on one level, if you think you're not digital already, you're wrong. I mean, you've all got your phones out during the boring bits of my talk, okay? Everyone's in a digital world now. And so what we found is, as we went to emergency remote instruction to cope with the pandemic, we created all sorts of flexibility options for our students, and now we need to move forwards into digital native versions of that rather than back into our old habits. And so that's a real challenge for us going forwards. We need to keep working on those competencies. There's something in the order of 40 of them on that page. They will evolve over time. Our friends in industry will say, this is something that we see emerging, you need to add that to the list. We need to keep understanding in a deep way how they contribute to the engineering identity and to the way in which we teach PBL. Flexible learning environments. What is the right space to teach a group of groups? Should we have all 9 of the windmill teams in the one building, or should they be spread all over campus? Or, because the problem is they're from different sub-disciplines. So if you want all the mechanicals in one space and all the materials in another and the electricals in another, what do you do when you've got an interdisciplinary project? Do you relocate them? Is it just about giving them good Wi-Fi, or are there other arrangements that we should make? That space is no longer a physical thing, and I've heard people speaking of the fact that space-based analogies, learning spaces, are in fact not helpful anymore because so much of it is not about the physical existence. Intercultural and interdisciplinary projects. We are well past the point where a single discipline can save the world. And so our engineers, we very much agree to that T-shaped engineer. You must have a discipline expertise, and you must go deep enough to have discipline expertise, but you must also be able to work in disciplinary teams. You must be able to work with people who don't necessarily see the same way as you. You don't necessarily have to see the same world the same way as they do, but you have to understand why they see it that way and how you can translate to work with them. And so there are a lot of different elements going forwards in the future. We are constantly trying to improve our practice, certainly as we come up on our 50th anniversary. But we have been doing problem-based learning for a very long time now. It is the ethos of who we are and what we do. It works effectively. We would absolutely recommend it to you. But where we're headed now is to try and unpack it from just one project, one semester, one team, to be broader and richer forms of problem-based learning that start to build the kinds of skills that Aldert was talking about earlier in the day. So thank you very much. I'm going to skip through my bonus slides at the end so that the next speaker doesn't have to deal with them. Thank you very much for your time. Appreciate it.
Thank you for the lovely presentation. I call now Professor Francisco Vasquez to the stage. He's Associate Professor of Mechanical Engineering. He's been the former Director of the Integrated Master of Mechanical Engineering. He has a background formation on electrical engineering, and is currently the Pro-Director or Pro-Dean for the Education here at FEUP, and is also, as everybody knows, been leading or pushing forward the process of updating or transforming our previous integrated masters into bachelor and master programs. Thank you very much, Professor.
Thank you very much for the opportunity to be here. Let's take the stand. Just me give a few words about FEUP. We are in the center of a traditional exporting region with a lot of traditional companies, and nowadays we have a lot of high-tech companies exporting, and which are changing all our export profile. We have some new companies, some new exports on renewable, electric mobility, smart grids, and so on. Besides to the traditional textiles, metalworks, and on all this stuff, we have more and more high-tech exports. We are also a driving partner for the Portuguese startup scene, included, of course, in all these European startup initiative. And so we, in the middle of the North region, which is a traditional exporting region with a strong focus on entrepreneurship and innovation, we are strongly committed training highly skilled and ethical professionals, training the future leaders in the area of engineering, and fostering high-tech entrepreneurship. We are in the middle of a big change in the north region of Portugal, and also fostering innovation. The Faculty of engineering, we are dealing with 8,000 students, with 350 faculty members, 420 technical members, among 2,000 staff globally. And we receive every year 2,500 new recruits, new students. But for the undergraduate studies, where I will focus my presentation, we receive around 1,200 students, new students, freshmen, every year. So we went through these last 2-3 years through a huge curriculum redesign, because in August 2018, Portuguese government decided to discontinue the integrated masters. We had, until that moment, till last year, 5-year degrees for graduation of engineers, BSc plus MSc, integrated curriculum. And so we have taken the required steps to change our curriculum. In October of 2018, FIUP set up a task force to redesign its curriculum. In 6 months, March 2019, a set of requirements and guidelines were approved by FIUP governing bodies. And in December of that year, 2019, the program director submitted the new curriculum for the university and accreditation bodies and so on. So we have started the new BSc plus MSc curriculums in September 2021, let's say a little bit more than 6 months ago, just that. It was for us a big opportunity to look again to our curriculum and to promote a wider implementation of the Bologna model. Student-centered pedagogical strategies. We have enforced a lot about that. We have a huge effort on student-led extracurricular activities as pedagogical strategies, organization of technical events, organization of engineering competitions, participation in engineering competitions. Our big focus is in increasing the overall student engagement. Student engagement is our strongest effort. And participating in this North region, in this ecosystem, we need to reinforce entrepreneurship skills among our students. We need really, as a country, to invest in high-tech startups. So this is crucial for us. Of course, it was also an opportunity to implement a common curriculum structure for all the FIUP programs, which was very important, and also an opportunity to get together all our major stakeholders around the curriculum redesign, and we have involved a large number of engaged participants. As a starting point, our employers, or the employers from our students, see our students, they are highly appreciated in what concerns their technical skills, in what concerns resilience, ability to deal with complexity, ability to deal with uncertainty, their mental flexibility, teamworking capabilities, and they are very much objective-oriented. But they must still develop a lot further the durable skills, soft skills, entrepreneurship skills, self-confidence, creativity, their network capabilities in what concerns professional networking capabilities, and leadership and negotiation skills. So this was one of our starting points for the curriculum redesign. Of course, we have set up a curriculum development plan, and we went back to look in what are the next generation engineering skills, which have been talked about here a lot, of course. And we have technical skills, more soft skills for the students. We have go through all those engineering skills. We have discussed them a lot, and the big questions, the big challenges were how to include them in what we have a kind of traditional curriculum, how to evolve that traditional curriculum in a soft and continuous way. So some of those big challenges, how to integrate arts, humanistics and psychology topics within the curriculum, more emphasis on transversal skills to promote a broader education, how to open the quite closed curriculums to other engineering topics to increase awareness and exposure to other perspectives, how to strengthen inter and multidisciplinarity in the curriculum, very important, more emphasis on systems knowledge and systems integration and knowledge integration. And one of the most important questions, how to enforce an explicit improvement of entrepreneurship skills, high-tech entrepreneurship skills, promoting, and we are promoting opportunities to improve it throughout the curriculum. In what concerns internship opportunities, we have already a long history from having final master's dissertations done in industry or in services or in research and development institutions. We will have now, as I will show later, internship opportunities during the BSc and not just during the MSc. And particularly for myself, it's very demanding, it's very attractive, how to integrate student-led, what they call portfolio enhancement activities within the curriculum or as extracurricular activities. We are working a lot on that topic. And finally, but at the end, but not the least, how to increase the overall students' engagement. It's very important to have engaged students. We have a lot of very engaged students. We need to extend that to 100% of our students. And this will pass to the redesigning of the learning spaces and some other aspects. In terms of implementation, of course, we have a semester-based structure that we will keep, and that semester-based scheme is based on 5 course units per semester in a 20-week semester with classes during 14 weeks, a midterm break plus final exams. Elective curricular units are usually during the second cycle, including some open selection curricular units. This was what we have before. At the end, final semester, MSc dissertation, mostly done in working context, as I said before. So the implementation basically passes the redesign of few curriculums, passes through the embedding some soft skill electives. We will place them at the MSc. These soft skill electives are short courses, 1.5 ECTS, a bolting-on approach. For the moment, we have long-life employability, leadership, negotiation, communication, and other short courses will be implemented. A set of other engineering electives, also short courses during the BSc. An internship opportunity at the end of the BSc, is that the green square, a mandatory 160 hours internship that all students must pass at the 6th semester, and for the moment, as extracurricular activities, a lot of student-led activities from the just organization of engineering competitions, organization of technical events, and also participation in engineering competition. For this year, which is the first year for the new curriculum, we had more than 300 organizers and more than 800 participants during the first and second semester. Okay, the second semester is just starting, but we already have those numbers. We are talking about a little bit more than or around 7,000 students, so we are just covering a small fraction of all those students, but these numbers, we think that will increase very rapidly. Next steps, 2-year plan. Of course, we have just started this new type of curriculum. We will have a turning up phase with the integration of new soft skill electives, of new other engineering electives. We need to include also arts and humanities electives. We need to set up an internship for all program, promoting closer ties with surrounding companies for the 160 hours internship at the end of the BSc. We need to develop new entrepreneurship opportunities. I will talk a little bit later. Centered on student engagement, always. We need to increase the multiplicity of student-led activities. Student-led activities are amazing in what concerns students' engagement, student motivation, and learning around those activities. Design also of new student-centered activities, always promoting student engagement through the contextualization of learning. And of course, dealing with the unexpected. These last 2 years, we started to prepare this curriculum redesign in 2019 with 6,000 students, and in 2021 we have around 7,000 students due to some changes that were made in the University of Porto, and due to also some decisions from Portuguese government, and due to some decisions of our governing bodies. So this is moving, always moving. For further steps, this is just a personal perspective. I foresee that we will need to include some transversal curricular units, proposing 2. One around engineering fundamentals. At the very beginning, between first and second semester, freshman students, we have around this moment 1,200 freshman students. A course unit with a 2 weeks duration, common to all engineering programs, selecting a core of 6 engineering topics, in civil engineering, chemistry, electrical, informatics, industrial management, and mechanics. Linking system models and required advanced maths. That's the possibility. 2 master classes, followed by hands-on confirmation of the modeling correctness of physics stuffs, of system stuffs, with a double target, highlight multidisciplinarity of engineering topics, and to reinforce the need of advanced maths among the freshman students. A little bit later, during the 5th semester, we should have transversal projects entitled something like Engineers Design and Build Things. Of course, including all the engineering programs, for the moment 1,200 students, a kind of engineering competition groups of two students, 600 teams, targeting the design and construction of small prototypes within the context of specific programs, and involving at least the use of CAD/CAM software, 3D printers, and specific sensors, actuators, and controllers. Engineers need to know how to build things, and of course, this will require an infrastructure, student-centered open labs, which we do still not have, and these have a triple target, or may have a triple target, underline multidisciplinarity and interdisciplinarity, promote creativity, and promoting entrepreneurship skills among students, and again reinforce students' engagement, which is really the most important focus that we have now. Is we have 30% of very engaged students. We must augment that, and we must also reinforce entrepreneurship skills, creativity, and so on. So I would just like to finish my presentation stating that change is the only constant, and it's a great time to be and to educate engineers. Thank you.
Thank you very much. We have time now for a second round of questions. I have mine here in the books, but I hope the audience also pose their questions. And I ask our moderator and the keynote speakers for their contributions.
Is this one working? Yeah. Sorry about the dramatic pause here. Thank you so much, everyone, for very informative, very structured, very straight to the point, provocative in a very healthy way, I must say. It seems that it all comes down to the same buzzwords, right? Creativity, student-centered, like, I would say even like a more, with all due respect, a more British approaches like this, like pastoral care, like mentorship, which I'm very much in favor for. Inclusivity and diversity, project-based learning, challenges that pervade courses. And I do believe that this is quite interesting, I would say. I wonder if the audience has some particular questions on this kind of buzzwords, perhaps, or something more specific. I have my own kind of interrogations, but later on.
May I?
The words are the same, doing it is very different.
There you are.
Yeah, I think there's a difference between using it as a buzzword and living it as a philosophy.
Absolutely. What?
I have a couple of questions to Professor John Mitchell. You told us a story that started in 2012, and there was a plan or an idea behind it. And one of the questions I have, and I think is also subjacent to all these strategies, how do you measure or how do you confirm that it was a successful strategy? For you and I have a question that is, it's a mean question, that is, if your students could choose, do you think they would still choose PBL as a teaching or a learning method, or would they go back to the exams? And that's it for now. Thank you.
I think it's a good question. I think and it plays a little bit to the buzzwords. I think, what you have to be clear of at the beginning of any curriculum change project is what, for your institution, are the things you want to get out of it. And the reason that UCL looks different to Aalborg and what was outlined there will look different again is the cohorts you have, the demographics you have in staff, in facilities, and all sorts of things are different. And so every model is going to be different, although they draw on many of the same influences. And I will happily admit of drawing a lot of influence from Aalborg, from seeing the weeks in Sheffield that inspired some of how to change the world, as they say. To steal from one source is plagiarism, to steal from many is research. I think, and that really then influences what it is you want to measure. And we wanted to give our students a different experience. We had very good exam grades. We had very good employability rates. They weren't often you see many of these changes come about because of some crisis, but we didn't have the normal sort of crisis to address of something, desperately needs to improve. Our national student survey scores are not so good, but that's a different story. And so really we're now in the process of trying to evaluate that, but it is quite a long-term thing, because it was the attitude of how our students adapt when they get into industry, how they succeed in industry, how they feel about how we have prepared them for industry, our key objectives. And so we didn't think we could or wanted to be measured on things like exam marks or other sorts of assessments. So that's still ongoing, despite the fact we've had 4 years of graduates come out the programme now. We're trying to follow them and track them as they go into industry.
Yeah, so I think your question about would Aalborg students prefer a more traditional model, I mean, we've been doing this since before they were born. In fact, we've been doing it since before I was born. They know what they're getting into. There is a subset of the cohort that lives in Nord-Jutland. They don't have another higher ed option. They go to university or they don't come to us. So there is a certain element of that, but they know what PBL learning is. They know why it works. If I can split the hair on it, our graduates don't regret it. Some of our later year students, I think, are certainly wondering, why can't I just solve equations and be done with it? And so there is a certain element of, we do have to keep making sure they understand why these skills are important, and we show how it's not just wasting time to consider stakeholders, that being right isn't a compelling argumentative tool. Like if you go into a room full of non-engineers and go, we have solved the equations for you, here is the right answer, and the bridge is going there. We're going to need to buy your house, your farm, and your house. We're going to bulldoze them, but it's the best for everyone. Why are you looking at me like that? So being right isn't enough. So I think that there is a certain element as they're going through the degree that they see at the start, go, oh yeah, this is what I came for. And then I think it sort of dips a little bit in the later years. And then they get in their first job and they go, oh, they were right. Yep, it is not about solving equations. It's about all those skills that you saw on that sheet. And so there's a certain retrospective vindication of the model that they see that the things that matter are the things they got from the PBL. So part of it is not so much managing the teaching, but managing the expectations of students. But our graduates understand it's the right answer, and our employers and so on. We've got some great numbers of, I think, you finish an Aalborg degree a year quicker on average than other universities because of the model. It just works, and the projects actually build deeper technical knowledge than just talking at them.
But if I can add to that, if you are changing the curriculum, I mean, obviously Aalborg has been doing it for a long time. If you're changing the curriculum, there will be pushback from the students. There will be students who, I had students banging on the table. I came to do science and hard sums. I did not come to write reports or work in teams. This is not what engineering should be about. I should be solving sums. And that managing that expectation, and it takes a little bit of time for that to work out of the system. You need support from the upper levels of the university that there will be wobbles in those first couple of years as things, didn't go quite right and the students weren't quite coming in. They talked to someone who was here 5 years ago and thought the degree was as they were would be as they expected, and it isn't. It does, there's got to be a bit of holding the nerve in the changes, because you are shifting an expectation, and you are challenging the students. You are making, by definition, if you put students in a problem-based environment, having to think about stakeholders, that can be uncomfortable. It's trying to push them out of their comfort zone. And uncomfortable students can be noisy.
Any more questions? Commentaries? Over there. Oh, sorry about that.
This is one of my standard bugbears, which is how do you differentiate between students if you're doing the group work? I mean, from both of you, and I know I've done this myself, because quite often if you've got lots of groups, you can get people hiding and all these other things. I know you do background in how to do it, but have you got any particular strategies to make sure that people get the marks they deserve and get the learning they need when they're doing group work?
I think there's two subtly different points to that. One about getting the marks they deserve, which I do believe is important. The other is, well, which I think is less important actually, getting the learning they need. If you're working in groups pass and fail. In industry, it pass and fails. I mean, it depends how much of the degree it is. There is a certain element that's part of the learning outcome, is to be able to work in groups, and therefore I think we've been guilty of it, certainly, of trying to over-engineer our group works to say we must pick out all the individual bits out. And I think you can get yourselves, we do things to support the individual, and we do support the teams we can differentiate. But I think you can also take it too far, and there has to be a bit of your group fails on the way it works together, and that's.
Yeah. So first, you explicitly teach the team skills in parallel. So you actually put marks on how is your team functioning, and can you explain how your team is functioning? One of the big challenge with a student project is that there's a 15-week karma horizon, right? Because everything that happens in this team has to be sorted out in the next 15 weeks. And I'm sure if you look around this room, there's someone in this room that you've been in a project with that let you down because life got in the way, and you went, that's okay, we work together, we'll sort it out later. Okay? As professionals, you have ups and downs, and people carry each other, and it's back and forwards. And in a student team of people you've never seen before, never met before, and won't have anything to do with after May, you don't have that luxury of going backwards and forwards. And so I think John's point about, well, teams should all get the same outcome, because that's basically how it works in life. Nobody says, this molten pile of slag that you have produced that's still on fire is a real problem, but we love your work. Your work was awesome, you can have a pass. That's not how it works. There are absolutely tools that can moderate. There's the CATME software out of Purdue University that is widely used. At Charles Sturt, we used a product called Spark Plus out of UTS. Where that was really good was it allowed them to rate the reality and then rate themselves and the perception. And so what we got was a measure of, are the contributions equal? And then we got a measure of, are the contributions how you think they are? And so we found that we had some teams with hugely skewed actual contributions, but we as a team know that I'm only doing half the work, and everybody agrees that there's only 3.5 people's work being done. But because we know I'm the guy doing a half load of work, everybody's okay with that. They only ask me to do half a load of work. And so that ability to understand how the team is working allowed us to moderate through that. At Ullborg, having close mentors, so if you have interaction constantly with them, you can see who's hiding, and you can see who's hiding because they don't want you to ask a question because they're shy, but whenever you ask them a question, they answer it thoroughly. And so you're like, well, that's an introversion thing. Sorry, I didn't mean to point to you like that.
No, that's fine, that's fine.
Yes.
It's all about self-awareness and students being aware of their,
Yes, but I didn't mean to call you an introvert.
That's okay, don't know.
So understanding that versus the student who's not turning up to meetings because they don't want to be asked a question because they haven't contributed. So I think that if you never talk to them, have no idea about the team or how it's working, but if you're actually asked them to do it, and also at Ullborg, we interview them as a team, and you can ask the questions, you can see who knows what and how they've contributed. But it's one of those perennial things that people love to complain about. But if you scaffold it of not just working in a team, but learning how to work in a team, and your ability to learn those things is 20% of the marks for this subject. So if you want a high distinction, not only do you need to do well, the other thing is you've got to make sure the project's too hard for that one superhero student to go, I'm the smartest guy here, I will do it all. You've got to stop that from being the possibility. You've got to make sure it is actually a 4-person project for a 4-person team.
The other thing you can do, of course, is make sure that you need different skills.
Yeah, and that's where the interdisciplinary projects work really well for that, because they can't do it all. And
Okay, everyone. And a final question, I would say, so that we can indulge ourselves with a bit of coffee. Yes.
They want to know why we're taking their farm up.
No.
Alguém tinha
Where is it?
Is there anyone? No.
Yeah, chap on the first.
Yeah. So, okay. So to Francisco. So the question is the following: you present us an overview. What is the let's say the idea for the future? Right? What kind of resources do you think should be on the top list to make that a reality, basically? So what kind of physical resources, human resources, what kind of preparation we should do for that to become a reality? For the coming, for the new versions of the project, of the programs.
Yes, it's okay. Kind of resources, of course, we will have the new building for laboratories. That will be very important for our students. We have laboratories within the departments, and those laboratories are not open. They are open to the students for that program, especially for the students for masters. But for the undergraduate students, I feel that most part of our labs are mostly closed because labs are attached to some curricular units. We need to have open labs. We need to have, students must have the opportunity to go to the labs and to build their prototypes and things like that. They must fill the labs. I think that's one of the major modifications that we need for the future. Otherwise, and that will be one of the ways to promote entrepreneurship. The students must be able to implement their prototypes, new ideas, and they must start thinking about how to make money in the future with those ideas. That's one of the axes. The other one about increasing the student-led activities, there is not need of much thing because the departments and the programs always support those activities. We need to increase the student engagement to pass to another level, just 20-30% of the students nowadays to much bigger numbers, and that will stress a lot the use of the rooms, computer rooms, the flat rooms, and so on, because those rooms must be used for the competitions, to organizing technical events, and must be shared with classes and so on. It's a nightmare for the Centro de Eventos, the guys here at PhilP that organize all those schedules for students. There are not enough spaces. Otherwise, there is not a need of some big investments on that part. And then we need to have the faculty members more oriented also for all those kind of student-centered activities, student-led activities, and so on. But that's, I think that will evolve with time.
Okay, everyone, I think we can call it a part of the day and go and have ourselves doses of caffeine and come back for a most incredible roundtable, enticing, talking about student self-awareness, future modular rooms with Nespresso machines and, ovnis and all that kind of stuff. Thank you so much, everyone. Let's go for the coffee break now. Thank you.
Back here at a bit, 5 minutes past 6, 4 past 16:35, so we can keep up with the schedule. Thank you very much.
One of the things that's always been engage more with CDIOs.
Okay, everyone, welcome back. So, now it is the time that I am actually entitled to ask a few questions. I've been pouring it up, and so interesting, so many challenges. I've talked previously about this buzzwords or this kind of thing. Let me be a little bit radical, actually. And cope with a little bit of my personal take on it. Sometimes it feels, as a citizen, not as an educator, that I'm seeing redesigning of curricula as something that is very appealing to newsletters and to kind of marketing approaches. And so the future of it, which is very good, I must say. And here's one question I sort of popped in between when we were having a coffee. What about this idea of training the trainers kind of approach? Because one thing is we have educators who are obviously technically capable and who have a very consistent throughout the years pedagogic approach, practically. But then what do you do, for instance, Professor, when you try to establish this kind of reform from within a kind of foundational macro structural approach, and you have to approach a head of a lab that has been doing the same kind of a thing for the past 20 years and tell you, you have to redesign your teaching skills to adapt to this kind of approach. So to go towards a student-centered approach, shouldn't we redefine the kind of pedagogical, creative skills, interpersonal mindset of the educators? And this is for everyone, actually, in the panel. So, but he's pointing at me.
So I think you have to approach different academic staff differently, in that there are some early adopters who you have to tell them to stop and then they ignore you and do it anyway, right? There are some who are 2 years from retirement and they're not interested in any change. I think the vast majority aren't resistant, they're reluctant. They just have a lot going on in their lives and they're willing to commit to a good idea, but they've seen so many bad ideas over the years that they're not excited yet. Where I think in Australia there's an increasing professionalisation of academia as a career. And so nowadays if you hire a junior academic, they are expected to do at least the first half of the graduate certificate of engineering, of online teaching. Okay. And so you have to do 2 full subjects worth, so 30 ECTS worth of subjects, that if you don't pass them, your job will go away. It's a condition of your employment that you undertake these subjects. And so what you find is that there are staff who are like, but I've been teaching for 30 years. It's like, no, you've been teaching for 1 year 30 times. You're still doing what you were in the 80s. Yeah. But there's a sense of you support the early adopters to develop things. You provide explicit training to the people who are new and don't know any better. You make the resources flow to the new thing that you want. So you start with carrots of, well, yes, that's great, but we're only providing the resources over here. And the other thing is that you then get the people who they know and respect around them. An academic in mechanical engineering is much more responsive to another mechanical engineering academic who says you should get on board than someone from Central or someone from on high. But you're absolutely right. Most of us came up through a traditional model. But the reality is that the traditional models only have another 10 years to go. And so if you're planning to have an extended career in academia, you're going to need these skills. So I think if you present it as this is a 10-year plan, not a by next semester thing, so we're going to invest in you over time and support you, you have a lot more chance of being successful than you do of saying, make everything different by next week.
Absolutely. That sort of we'd like to resonate with that.
A lot of what we've heard earlier, not from me, but from the other 3 of you, is this all project-based learning, which means, of course, that the staff have got to get together in teams. So when you start getting people together in teams, if you have an enthusiast, an early adopter, a leader in there, you do tend to drag all the people, all the rest of them along with them. So actually, by moving people out of there, this is me, this is my course, I will teach it the way I've always done, that disruption occurs almost for free.
Doesn't that sort of all comes down to time, actually? because it's like motivation, kind of motivational cycles. And then I sort of remembered the title of your presentation, so this idea of how much, how fast, in what way. And the question of the fast-paced kind of environment we're living today, and the kind of everything for today should be due to yesterday, and this kind of commitment with the students that, okay, this is project-based, but you've got 1 week, everything's about sprint, agile, scrum masters, 1 week to outline an idea, 1 week to, materialize it. I've been having troubles teaching in Germany because I allow my students for 1 month of doing absolutely nothing. And I indulge them with the luxury of time. So enough time to completely go, just read and get yourself, inspired by whatever. Do not feel pressured that you have to have a kind of an outline or a template or some key points. And then eventually they allow themselves to have those ideas and those kinds of creativity stimuli to sink in. And then they get a kind of an outline that is informed and consistent. So how can we envision the education, the future of education and engineering in times where, digitalization is getting so, ferocious? And how can we allow our students to have time to do something that I do, for instance, walking ethnography, just walk around and talk? Should we, also educators, are they going to be involved in that? So, how do you resonate with my crazy schizophrenic idea?
Crazy ideas. Well, I first want to go back to where we came from. Time. Also students, because if you want to change curricula, I think one of the most powerful agents of change are the students. Yeah, and I haven't heard that in any of the presentations, but I would recommend if you really make a vision, really involve or to benchmarking your curriculum, involve the students very strongly, because if students feel that you want to change your curriculum and they are, let's say, the best ambassador of change, so don't forget them.
Can I?
Of course.
Propose a challenge there. There is students, they have, let's say, a very short life inside university because they stay here for a short period. And very often the bureaucracy surrounding many of these processes is killing the ideas at the birth, because they want to come to you and say, I want a new cooperation with Singapore, and say, yes, but look, I have to analyze it, and this needs to be dialogued, and it takes years, and you killed the idea there.
It takes years.
So how do you solve that?
Well, I don't know your organization, but I presume you also have a sort of board of studies or a council of student association. Well, have members of this council in your redesign teams, so that you make them responsible as well and give them the input. And also that council, of course, that refreshes every year, but keep those members in your team. Mm-hmm. At least that's what we've always done, and we have very much appreciated always their inputs. But I don't know.
Student engagement is crucial, of course. I have no doubts about that. We must have a movement, and we must, I don't know how, we are starting with competitions, organization of technical events, and so on. And we must put all this stuff moving, because then they will ask more and more from us, and so on. And it's amazing when the wheel starts moving, it's amazing the results that we can achieve with that. No question about that.
Different perspective. Be careful what you wish for. Because the purpose of a bureaucracy is to make bad ideas happen slowly. Okay? The problem is that all my ideas are good and it's slowing them down. But ultimately, universities aren't a monopoly anymore. We used to have a monopoly on all the smart people. We used to have a monopoly on the knowledge, the space, the time, and the credentialing. And the one that will be the hardest to strip away from us is the credentialing. Okay? Salman Khan with the Khan Academy is better at teaching maths than you are. I'm so sorry if there's anyone from the maths department here, but we don't need you. Actually, we desperately need you to run tutorials, but we don't need you to deliver the materials. But at the end of the day, when a university, with its quality assurance processes, all those things that are so frustrating to deal with, because they make sure you do this and that, having done that, when a university says you know something or you can do something, the whole world takes your word for it, right? When you say they're an engineer, then the URACE accreditation kicks in, and when they move to Australia, we just believe them because they have a Washington Accord accredited degree. And so as frustrating as it is to say, oh my God, there's all these systems and they're so painful, they are actually what protects you. And so I would completely disagree with the fact that these bureaucracies are a problem. In my experience, the accrediting bodies absolutely want to accredit new and novel models of engineering education, and they are desperate to say yes, but they have responsibilities to meet those standards. So your question is, how do I put this round peg into your square hole? Right? Not, oh, they only take square pegs. Like the whole point of being round is that it's the right answer. And so that process, as much as this is frustrating to deal with it, it is assuring the quality of what you do. And at the end of the day, that is the value proposition of universities that will be the hardest to strip away, because other people can sell them the content, other people can provide them a learning environment. In Australia, we certainly have private providers that are selling usually at the business degrees because they don't require expensive labs to run. But the one piece they can't take away is the 100 and how many years of credibility that the university has. Right? We've been doing this for over a century now, and when we put the stamp on them, you know it matters. So, I mean, by all means, rage at the bureaucracy, but on one level, it's actually the value proposition of a university.
On the other, there are university bureaucracies which can be extremely unhelpful. I've done a lot of accrediting in my time, and actually I've come across departments which are doing a very bad job because the university is forcing them into one of these square holes. So there is always the danger that someone can tell you what to do. And this is when we do accreditation. I'm not quite sure how it works exactly in other areas other than the UK, but actually you don't want the accreditation to say this is how to do it. The accreditation must say, we see how you're doing it. How well does this match up against the requirements and the quality required for those jobs? So actually, when people say, this is how to do it, that's when the whole system falls down, I think. And that's why people do what they've always done, because no one ever went broke at buying IBM, I think was the classic line there.
It's not legislation or accreditation requirements or even university policies. It's that the database that it's stored in only lets you choose 2, 4 or 6. That's why there's no 5s.
Exactly.
And there's nothing stopping you other than force of habit.
And we've all seen people saying that a course must be 30% this and 20% this, or else we won't accept it. So, there are these things, and actually the question you have to ask yourself is, why are you forcing me to do this as well? So, there are different views of the bureaucracy, and
But usually if you go to the bureaucracy with a solid explanation that's based on a deep thought process, they go, oh, well, you can have an exception, because that's a really good idea.
But you didn't mention health and safety either, which is the other one.
Of course, the accreditation is to ensure the quality level of formation, of course. But there are more than the quality level, because we have students that will be professionals, and for instance, we need to foster entrepreneurship. Because it's that the society wants that, high-tech startups and so on. How can we do it? How can we achieve it? That is kind of besides the accreditation, because the accreditation is the not basic, but the quality level, if it is insured or not. But we need to do more. We need to think further than that.
Talking about accreditation is it only does the threshold. It guarantees that the meanest student on your course,
of course,
who passes, has fulfilled those requirements.
The best thing you can say about your course is it's accredited. If that's the best thing you have going for you, it's like we meet the minimum standard.
Yes.
And I think this is part of that challenge with, I call them the enterprise skills, but the durable skills, is that everybody, you need to be this smart to be an engineer, And being better at the technical skills doesn't really help unless it's one of those roles there. But the better you are at those durable skills, that's valuable in every context. And so saying we're going to meet this threshold and then build in that understanding that if what your region needs is entrepreneurial engineers, then you should be serving your community by doing that. So how do you fit? Because every little bit of durability that you add in that framework makes you a better engineer, makes you better able to do the things that you do, or makes you better able to sell the right answer when you've used your technical skills to find it.
So what I always say is that technical skills gets you your first job, the durable skills gets you promoted. And so you need both of those.
But not get promoted straight away. I wonder if being strategic in terms of the level of involvement of students in the various domains within, not just redesigning curricula, even like facing the monster that is bureaucracy machines within university, how that kind of co-responsibility might be a key, adapting to specific needs within institutions, academic cultures and all those kind of diverse geographic, and physical and cultural and academic landscapes. Could that be a way? And another, crazy idea to add up to that, why don't we just, forget about marks in the mathematical terms of it? Let's just say to our students at the beginning of the semester that they have full A's and they have to write down an essay dated to the last day of the semester saying why they got a full A.
It's doable. There's certainly paradigms where mastery learning, where you get multiple attempts to get to a single threshold. So your driver's license is like that. You don't get a A or a B for your driver's license. You just get a yes or a no, and you can have hopefully not too many attempts at trying to achieve it. It really changes the way in which the students learn. One thing that you do find is that programs with strong internship programs, so when they spend a lot of time in industry, start to feel pass-fail. So even if you are grading them A, B, C, they realise by semester 8 that the job that they have and the projects they're doing in the job and the skills that they're building in that way are far more valuable to them on the job market than a couple of extra grades. And so you see this sort of weird inversion that engineering students aim for that credit distinction threshold, and student engineers tend to just get passes or high distinctions depending on whether they're inspired by your project or not. But they don't do the extra work because they're too busy being engineers, and it's the value of the portfolio, the PBL competency statement, all the things that come with the authentic practice are actually more used to them than a couple of extra marks. And it breaks your heart as an academic, seeing that they clearly understand what's required to get more marks. They clearly are capable of it, but they're making an informed, rational decision to opt out. And you think, well, that's wonderful, durable skills, but I'm a little bit rejected. Absolutely, and it's beautiful, but it makes me sad. Because more thermodynamics isn't going to help them. Like it's the projects are more valuable to them moving forward.
The model I've always liked that I haven't seen implemented is actually having a project down the middle and feeding in at pass level the knowledge needed to do that project. So you have to fulfill those outcomes, but actually how good you are as an engineer is based on how well you do. I don't know if that's a model that you've seen implemented.
It's a model I built at Chelmsford.
Okay, I'm only 3 years behind. Okay, 10 years behind? But yeah, I think that's the idea.
Yeah, that's what we did. We made the underpinning technical content online as a Netflix model, where everything was pass-fail, and you had, I think, the fourth attempt we didn't give you the points. So you got to have one go and be mostly wrong, another go to be mostly right, and a third one to get it basically right. But we said, do it until you get it right, and then build that into the project. So the project still maintained the marks, the portfolio still maintained the marks, but the underpinning technical content was just a yes/no. And what we found was that worked really well, but once they got out into the industry placement parts, they stopped doing the high distinction portfolios, because we're in a situation where you're working daily with other professionals and you realise you've got 3 years paid work experience at this point. I don't need a distinction in this portfolio. I need to pass. And so they became much more utilitarian about the way they engage with the curriculum because they were getting the real practice. They sort of felt a little bit like they left us behind.
But I think it's implying there that if they're able to just get a pass, they must be very, very good to plan. They must know exactly what you have to do
they were
for all of
capable
those,
it,
and they could have done it.
but they were too busy being engineers.
Well, that's an optimization. They've just done the optimization. I mean, that's
I mean,
they just have the
heartbreaking,
first.
but it's an accurate thing. Yeah.
And I wonder if and this sort of resonates a bit what you said about student self-awareness, which I very much appreciated. So you're basically sort of saying, correct me if I'm wrong, that the adequate context sort of organically builds up that kind of self-awareness of what is really important within my own profile as a future professional. And as we move students to those kind of real life contexts and kind of explorations, they understand that it's not just about a number and a sheet of paper and a diploma, but it's about building up that kind of specific toolkit, and that sort of, gives them that insight. And then you legally oblige them to write down their self-awareness profile, which is very, very interesting as well.
Yeah, well, but the act of writing it is incredibly powerful.
Absolutely.
If you know that you have to be able to not only do it, but also explain it.
Yep.
Because explaining it is a really powerful skill. But what they find is that they come in out of high school where it was entirely technical skill in maths and physics that got them into engineering. And over time, it slowly dawns on them that it's actually the durable skills that matter. And so the more authentic project work and the more interdisciplinarity and the more your inputs come from somebody else's outputs you have to deal with, the sooner that penny drops that higher numbers aren't going to help. And so, I mean, the saddest students are the ones who don't get that until after they graduate and they get into their first job, and then they realise it's work, not assignments. And they're actually going to have to do this every week. And that if they don't do it well enough, they'll be made to do it again. Like, it's not just you get a bad grade and ignore it. It's like, no, it needs to be done. And so the sooner you can get some of that consequence, some jeopardy into their life, they can start to... I talk about the difference between engineering students, who are students who are studying engineering, and student engineers, who are engineers in the student phase of their career. And if you emphasise the student engineer mindset, where you want to value the engineer behaviours, not the student behaviours, and don't get me wrong, the student behaviours are fun, that's why we're on campus, right? But emphasising the consequence, and they soon realise that the technical superiority isn't the pathway to success for very many of us.
So did you have any courses where you had your project and you asked the students to choose the learning that they needed to feed into it, or didn't you get quite that far?
They certainly choose from the underpinning technical, and I'll just be clear, I'm talking about my previous role at Charles Sturt University, not my current role at Aalborg. They have the freedom to move through our Netflix curriculum to support their learning.
Excellent.
So if you have chosen a water-based project, you're going to go up the water branches of our topic tree. If you've chosen a structural one, you'll have to go up the structure piece. There are still some compulsory hold points where you can't go past this level if you don't understand these things. Doesn't matter if you want to be a water engineer, there's still some basic statics that you have to understand.
Because that gives them the lifelong learning skills that they need to reflect on.
Managing and moderating themselves, yes. Yeah, and so I think that model of the project is at the centre and the technical curriculum supports it, not the technical curriculum's at the centre and the project's where you demonstrate it. I know you spoke of why do you go to labs, and a lot of them think it's to prove the things we saw in lectures, rather than why do you go to lectures to explain the things we saw in labs. Like, those are a total inversion of the other. And so if you can focus it around this is why you need it, we find that if you give them the freedom, they do it completely out of order. Like, we've got first year students running up to the second and third year parts of our curriculum because they're inspired by it, and our academics keep asking them more questions about the chemistry and the water quality, and they keep going, okay, I'll learn some more. And so they do a bunch of third year water chemistry for their first year project and then come back and do first year science because we've made it asynchronous. And so once you lose it must be done in this order at this time in this place, you get all sorts of flexibility about the way in which they engage with it.
If they miss anything out, in a way you don't care because you know that they can pick it up?
We know they can find it. There are some things that we truly care deeply. And one of the points...
You trust your students, right?
Sorry?
First of all, you trust your students. You know they're going to find
Yep, we have to. And we're monitoring them, and you engage in mentoring with them. But we've also made it very clear that these are compulsory, and if any single one of them is missing, we're talking 3-hour modules, we are absolutely literally willing to not let you progress in the degree for the lack of one 3-hour module. Now, we gave you a year and a half's notice, you knew this was coming, but there are things we say, this is absolutely threshold. You're not a second year civil engineer if you do not understand equilibrium. You can't keep putting that off. You have to eat your vegetables at some point, right? You can't just keep eating the chocolate. But that flexibility, they disengage like Netflix. It's crazy how they will completely upend your curriculum to support the things that they are needing to learn for their projects or the things that they're just inspired by, rather than going on the schedule of when we think we should teach them. And so that model of, if you've got that ability to give them some flexibility about when they engage with it and then make it about the projects, you get all sorts of flexibility, particularly for the high achievers. You just keep pushing them. That's a great prototype. I'll ask you another question, and I'll ask you another question, I'll ask you another question, and they can just keep digging.
I think for this faculty, it's much more important. They have a rigid structure for a curriculum. How do you come there?
Sorry, how do you
get there?
The rigid structure?
Away from the rigid structure.
So we had the advantage that we didn't need to meet that rigid structure. So we read the rules.
I mean this faculty has it.
So I think understanding how rigid is it really, and understanding that the places where you're applying and the people you have to explain your non-rigidity to, that you're bringing an explanation for why this works. So it is my round peg to go into your square hole, but let me explain why the lack of corners isn't a problem. And so I think, now don't get me wrong, if your university requires you to offer 4 subjects every semester and they must be equally sized, then you've got structural pieces around that. There are ways to do it. We put our flexible curriculum within standard shaped subjects. And so the subject wasn't do exactly this technical content, it was do the technical content that a first year should do. And so they had flexibility about the pathway they took, but the amount of it was kind of fixed. And so there are ways of, our portfolios are like, well, bring us examples from your placement of things you've done. We don't know what the examples will be, but we know there'll be an example that goes in it. We do it for capstone projects. We have no idea what the capstone project will be, and every capstone project is different, but we expect them all to meet certain threshold requirements. And so we're already comfortable with swapping out different versions per student for a capstone project, as long as it meets these thresholds. We're much less comfortable doing it in other places, but the other thing I would say is if you're going to do it, warn the people in advance. Don't just turn up. Say, we've got this idea, how will this mess up your world? I don't want to create problems for you, but how is this an opportunity? And I certainly had conversations where I spoke to 6 people about a thing I wanted to do, and all 6 of them told me, I think that's great, but the other 5 won't let you do it. I think that's great, but the other 5 won't let you do it. And I went around and they all told me the same story. I thought, maybe, should I tell them?
So the idea is that it should be kind of cumulative. It should be like a case by case, it's like, clinical psychology. Do you believe in that kind of a...
Don't ambush people. Go and tell them. I mean, when we were accredited, we started by going, would you be willing to accredit this? Let's talk about the trouble we will cause you when we bring this curriculum to you to accredit in 4 years' time. Let's talk about the things that you're afraid of. Ask your staff. The things that they're okay, what are they actually afraid of? Listen to what they're afraid of. Figure out why it's going to be a problem, because there will be some legitimate issues in there. But if you try and work out what's habits versus policies versus the legislation, you know whether you need to build new habits, change the policies, or liaise with government. But you've got to listen. You can't just go, here it is, lightning bolt from on high. You've got to talk to all the people who are going to be affected, the ripples that they're all going to send.
There'll be a time when you have to bring out your steamroller, though.
Yes, and you save it for the end.
Well, exactly.
I knew I had the Vice-Chancellor card. I'm like, well, the Vice-Chancellor says it's happening.
Exactly, but you
get it one of them.
Exactly, but you do need, you cannot get to where you want to without the steamroller card.
It's hard, but if you listen, it makes it easier. Because the things that they're afraid of are legitimate fears, and they're coming at it from a timetabling perspective that you haven't considered, or they're coming at it from a facilities perspective that you haven't considered, or a legislation piece that you had. I had a couple of them like, really? The law? In Denmark, we can't have elective subjects. No. What? So I think, but understanding what is the legislation actually say rather than what do you think it says or what have we always done. But I think understanding what's a constraint, what's a parameter.
But I'm just saying that there are people who will disapprove of change no matter what it is.
Yes. Yep.
And there is no argument that will work with them.
Yes, and if you can't change your people, you change your people. But most of them aren't resistors.
Yeah.
They're reluctant.
Fire them all.
No, you can't do that. You find out what it is that they're objecting to. And if it's just, I don't want to change this late in my career. I find most academics are really on board for good ideas. It's just that so many of the ideas they've seen don't look good in their perspective. They haven't explained why we're doing this change. They weren't consulted. It's like any other change management, right? Have they been listened to? Have they had a chance to put input in? And this is where talking to non-engineers about working on large socio-technical problems is so important, because just being right isn't enough. But a lot of it starts to not be about the project and it's about to be the people management of how do you explain it. The other thing is, if you are doing really good things, the early adopters from other places will come. So those people that do leave, you get to replace them with people who are on board with the model and are tired of doing the same thing over and over again. But it starts to be as much about change management as curriculum management.
May I challenge or confront those visions? I think Aldet spoke to us about the changing world and how we have to prepare for a changing world and different challenges. On the other hand, we have here the perspective that Ewan talked that we are the gatekeepers for the credibility of the education in higher in university. So how can you embrace change and at a certain time be the rock that becomes stable? So how can we overcome that paradox?
Yeah, that's a good question. So how to make your program agile enough to accommodate all the changes that are coming, and we don't know what changes will be there in 5 or 10 years. It's difficult. And I mean, we have been working on a master's where we said, going back to the students, for instance, we said, well, we want to have an agile block of 30 study points, so half a year, and we call that Master Yourself.
Okay.
Yeah? And the students define their own learning objectives and they fill it in completely by themselves with courses, with trainings, whatever. And it's approved by the Board of Examiners. And then it is part of the game. So that, I mean, by allocating such a block of half a year, it's more or less the size of a minor, then you adopt a type of agility or a resilience in your program, because what students choose today can be different in 5 years' time, but the layout of the program is still the same. So that's one option. Mm-hmm. Yeah, how to accommodate change. I've always said we have right now, I don't know how it is right here, but we have in Delft many very small courses, which is a disaster, I think. If you have big courses of 10 study points, for instance, then you can change content within the course without going to the administrative hurdles. Then it is the responsibility of the teachers, 4 or 5 teachers who may give that course, and you do that without changing on a high level the learning outcomes.
So part of the game is to avoid too much detail in a way.
Exactly.
So you go, these are my broad learning outcomes, these are my broad teaching methods, these are my broad assessment.
Now the University of Twente, they only have courses of 15 study points. Yeah? And they can change anything they like to some level, to some extent, without going to the administration, without going to the Board of Examiners, without going to the accreditation issues.
They just pursue their hidden agenda, right? They just undercover in a good way, I would say.
They build the flexibility within the courses.
Yes, okay.
So,
yes.
I think the other thing I would say is continuous improvement. So if you are looking regularly and you're talking with your industry advisory committees and your employers, you get a sense of things go from being best practice to good practice to old practice to bad practice. And so I think on one level, just being aware that our PLC subject is probably getting a bit out of date now, maybe we should look at it. Mm-hmm. Doesn't have to be done this year or next year, but you know it's got to be done. And so if you are constantly looking, if you only look every 5 years because you're only accredited every 5 years. I don't know how it is in Europe, but external advisory committees in Australia usually meet 3 times every 5 years, right? Once just after the accreditation visit and twice just before it when they go, oh my goodness, is accreditation coming? We should probably meet. The strong programs, they meet regularly and they're consistently providing that kind of feedback. And they tell you, is this a tweak that you can make to your PLC subject? Or do you need to split that into PLCs and SCADA? And so it's that sense of making sure that you are continuously thinking. All that stuff we expect students to do about developing their reflective metacognition, if you build the same thing into the way you review your curriculum, saying, well, it's not permanently fixed, we've got these main features to it, but we're willing to let go of some subjects. I've seen some institutions, Olin College in Boston, that everybody holds up as amazing. The thing I like about it, their subjects have a maximum 5-year lifespan. So after 5 years, they have to throw that subject out and build a different one. So at the moment, first year maths is called linearity. And so that they have a sunset clause that every subject has to be replaced and continuously refreshed. And so if you look at it as we need to get this right and then we can leave it for 20 years, you'll get yourselves into those problems. But if you look at it and say, this is the current version, how do we keep making the small, because we want to be at that point on the horizon, the steps are that way, we'll have to keep adjusting as we do it. It also makes accreditation very easy because you already have all the documents they're looking for. Because it's just this year's version.
What I hear is also that many people are afraid for the accreditation agencies, but I think this is what they like to see.
No,
They want to see an evolution.
No,
The inquisitors, right?
Yeah.
No, they want to support innovation. They want to support new models of doing things. It horrifies them that we're still working off 1970s technology. They want to see the field move.
The other thing, really powerful agent to that, of course, is disruption. So actually, things like, unfortunately, the COVID, which meant that all those people had to throw away their sheaves of overheads and decide they're going to be teaching in different ways. And indeed, you can create disruption internally as well, which does that. So you might put in one very different course that suddenly means everyone has to rejig themselves. So actually, the thing which is so dangerous, as you were pointing out, is the business as usual. I went to a meeting of my old department, and they went, here is our course, and it was the one I'd created 15 years before.
But if you look at the example that John Mitchell gave, they said, all right, we can't reinvent everything, but we can put this piece in. And so they gave room for people to be early adopters. So if you wanted to be part of the team that drove this, you could get on board. But if you wanted to be part of the team that ignored it completely and hoped it went away, they had space for that as well.
But there was also the ripple effect.
Yes, but what you find over time is it works. And so there becomes less and less people who, one, don't believe it should work, don't believe it can work. And over time, they start to hear it from their colleagues. Or you hear this whole, well, why is mech-eng growing? Because all the mechanicals go and do the scenarios and the electricals don't. So they're all leaving electrical for mech because it's a better experience. And so I think there's a lot to be said for supporting the people who do the right thing rather than just trying to punish the people who are just trying to carry on.
And as someone who's just giving up their current job, actually change of leadership is very important. If people are in post for 30 years, the same things will happen. So actually replacing those people, they may have been agents of change, but down the line, they're now agents of reaction.
This sounds more like political science now, which is the balance of power.
But the reality is that, I mean, don't get me wrong, you need the curriculum expertise, but actually getting it to work is actually getting it to work is a change management problem. It's as much about the human resources as it is about having the right curriculum model.
So if it's understood this kind of two-pronged approach, this can step by step, the ones that are early adopters, that they can actually engage in this kind of contagion to the colleagues that, step by step, the colleagues that are a little bit, resistant, they would eventually say, oh, he's actually doing something, I might try something different than PowerPoint for my classes.
Yeah, and so you find the people who try different things, they get great teaching reviews. And then when the policy is, well, you need to improve your teaching reviews, all the people who get good scores, what do they have in common? So I think that you need to find a way to support the people who try things anyway, and then you have to find a way to generalise it. And I think this is a danger of having a department of engineering education, is that you can pull all the people who can make those changes into this one area, and they all feel supported, but now there's nobody left in the actual departments to do the innovation. And so you want to find ways to make the rewards to doing these things flow, and some of them are extrinsic and some are intrinsic, right? I can't imagine what it must be like to stand in front of a lecture of 300 students who hate you, right? Because they have to pass your subject, but you are a inspiring and passionate person who truly believes in the power of transistor electronics as the fundamental building block of everything that... I can't imagine the waves of hate that... I got a bit of it there, thank you very much. But it's just I can't imagine what it's like to be bad at a job like that and to hate it.
But the other side of that, which I think is really important, is, and we don't give students enough room for this generally, is you must let people fail. If you're going to...
Yes.
Not everything that people... Not all change is good change, but actually, if people know that if they do something and that will end their career, they're not going to move away from what they're doing.
You'll let them fail upwards. They have to learn from the failure and improve their
Building
practice.
up on
But
it.
yes,
Yeah.
I've done that many occasions.
Oh yeah, it's not a monotonic improvement. It goes around and over, and some of the best.
But there has to be a
experiences.
culture whereby people are supported through these things.
Yeah.
Let me talk a little bit. You talk about commonalities, finding the commonalities, and let me bring it again to the students. Okay, bring it to the students, which is, I do believe that, well, I'm asking this to the panel, obviously, that finding these commonalities is all about optimizing these various dialects that students of or future professionals or future engineers have to deal with, which is, for example, I work within immersive media. I do not know how to code, but I know that to provide a perfect vertical slide that comes out of an European project, I have to understand that my developer has to get the SDK to K to this and put it on Unreal and do this and that, and I know how much time it takes, how it costs, but I'm not a developer. But I have to get into, which kind of brings us into this idea of what is collaboration, what is co-creation. Do you think that that is the kind of, do you all think that's the kind of creative mindset that we step by step have to share with the students or nurture with the students? This ability to speak all these different languages, not in depth, but to have the ability to go beyond obviously technicalities, and this is an old discussion. How would you cope that? And specifically now that we're in post-pandemic, soon to be full-on established kind of hybrid model, how are we going to do that? If it's a human-driven thing, and now we're talking through machines again, how is that going to happen, perhaps? Sorry, I talked about many, many things. It's my crazy mind. I'm so sorry about that.
I think on level it comes back to Aldrich's point of emotional work, is that, I mean, you can maintain relationships electronically, but it's very difficult to establish them electronically. And so, for all that I absolutely believe we can deliver the underpinning technical content online, you can't do the whole degree online. Even the fully online universities that teach engineering bring their students on campus for week-long intensives. And when you look into them, it's only after the first one of them, the students go, oh, finally I met everyone, I feel like I belong. You know, there's something about that in-person interaction that enables them to feel a sense of identity, a sense of belonging. And I think, talking of things we can't unbundle in the curriculum piece, it's that identity piece of what it is to be an engineer. You know, who is it that when you graduate that you want to be like? Those sorts of things are incredibly difficult to do online. And while you can, it's so much harder to do that online than in person that you shouldn't. There are delivery that is so much easier to do online than in person. It's much better to watch a video of me telling you theory than come to a classroom for me to do it. So there are some things, when you talk about hybrid, some things are best served in person. And there's a reason you flew us all here to be here, right? Rather than just having us beam in, because the conversation works differently. And we can exchange emails afterwards and it will work. And so while you can potentially put anything online, you shouldn't put everything online. And I think that, and again, it's that experience of those different disciplines. I mean, you sat and listened to the coder tell you about the bits and you went, oh, I kind of follow bits of it. But I trust your expertise. I'm an expert in my thing. I can see you're an expert in your thing. I will understand it well enough to be able to work with you in an interdisciplinary team, but I don't need both disciplines myself. And so I think but that's much easier to do when you've had the chance to trust them, and trust is much easier built in person. That seems to be, usually that's how it works. It's either in person or someone you know vouches for them. And so I think that's the kind of skills that are best deployed in that context. And it's like anything else. I mean, there are things we do in lectures, there's things we do in tutorials, there's things we do in laboratories, right? Because those environments suit them better. Well, now there's things we do in in-person studios, there's things we do in workshops, there's things we do by letting them watch videos because they're suited to that. And so I think it's perhaps, in a very European sense, you need to know which dialect to speak in which context, because some of them work in that way. But I think realising that you don't have to be an interdisciplinary person, you need to be able to work in an interdisciplinary team.
Yep.
And so you give them a chance to do it, try it, learn it, then they do more of it, then they do well, then they reflect on how it works. So again, like any other skill, you scaffold it up.
Again, what you were talking about, which is one of those, my favourite words that you brought up, is agility. Yeah. And I think that's so important for the students, and that's something which I think is much harder to get online. But I mentioned this, I've been told my daughter's becoming a teacher, so I mentioned agility, and she, coming from a social science background, didn't appreciate it in the same way. I think maybe engineers, because they've had such a history of being siloed, are being pushed into more of this. So I think that's very important, the idea of being agile, of being able to work in different environments at different times is so important. And I think that's something where we as engineers have had 150 years of doing it badly. So, there has to be worked at.
So that would be one of the biggest challenges. So now big juicy questions to indulge our in person and our online audience as well. So would you say, and you've all come from institutions that have sort of are quite avant la lettre, you're like, pushing the boundaries forward. So what would be your, let's make it really practical, TED Talk style, would be your top 3 big top tips for, future institutions that might be seduced by going into the baseline and actually restructuring their pedagogical models and approaches and be more human-driven, student-centered, project-based learning, etc., etc.
Seduced is such a harsh word.
Didn't just came from
maybe
lunch?
it means different things in Portugal. 3, you say?
Well, some top tips, I would say.
Clear vision. You don't turn it all upside down because it's fun. You don't turn it all upside down because they're buzzwords. And so, you use the word buzzword and I feel John go the same way as I did. The places that use them as buzzwords, it doesn't work. But if you truly believe that your mission is to serve the north of Portugal and its export-based economy by producing quality engineers who are able to engage in an entrepreneurial society, are business literate, are mechanical process literate, can contribute to the communities, the professions. And if you believe that by starting them with authentic practice on campus and scaling that to actual practice in internships and then as graduates, then that will hold you in the dark as you have to go to another academic senate meeting and explain the model again because different people came to this meeting than the last one. And so I think if you have the why, and I think all of us are up here because we have a different why. We've looked into our crystal ball and, we look at our crystal ball, it tells us where we're headed, and some of us get different messages, but we all know we're headed that way, and that's not where the curve has been taken. So I think if you have a very clear why of this is why we're doing it, then that will get you through the how and the what. And it will give you answers to the rest of the why. So why are you doing this? Because this is who we are. And I think we're seeing an evolution of, it used to be a degree was about what students should learn. It's moving to what graduates should be able to do. And I think it's moving through to who engineers should be. And I think so we're getting more of the why and less of the what and the how. And so if you have a very clear why, and then you look at that why and you can't defend upending your curriculum, we will produce Sheldon Cooper super nerds who solve the equations that are too hard for the graduates of other people's programs, primarily after completing a PhD with us. Maybe 4 units is the way to go, and don't do the project. So the why will carry you forwards in the dark times.
Okay. The one I was going to offer, which I think you've stolen from me, is sort of the meta of that, which is good enough is good enough. So once again, if you're going to aim to achieve perfection, you'll never get off the start line. So actually, you have to accept that it won't be perfect, that it will be a development, and that's a way of bringing people with you as well. But it's sort of a distillation, perhaps, of what you were saying, is that you have to move rather than worry about moving.
But I think that also gets back to that agility piece, is that if you're trying to design a curriculum that will be robust for 20 years, then you do need to get it perfect, because it's going to have to last for 20 years. And so many of the artifacts we make, we want them to last more than a couple of years. But if you accept that your curriculum is going to keep changing, then maybe you don't need to polish it all, because it's only going to be...
And if you do polish it, then that's an agent of reaction.
Yes, but I think being willing to say that's good enough for now, or that's our best effort, or
it's a good start. It's a good start, yeah.
Or it's time to go, we have to do it now anyway. Flexibility, yeah. Yep.
I think one of the key issues, we have been talking a lot about entrepreneurship, and I like much more entrepreneurial behavior. And I think you need in your faculty, in your university, an entrepreneurial behavior, and not only of the students, but also of the staff and of the council and of the board, everybody that obstructs, let's say, or that does not obstruct change, but really gives incentives if you experiment with a new type of education, come with new courses, say, hey, well, maybe it fails, but you still get an incentive, well done. And that's a culture that you have to make happen.
So I wonder if we could, you've got a question? Yeah. I wanted to open up a little bit for the audience as well, even if it's a round table, I suppose someone...
Well, it's a very big table. If this is the round bit, it extends all the way. Have I missed the huge invisible table?
It's the best we can do. Yeah. It's the best we can do with our scenography.
It's a table of the mind.
Absolutely, there you are.
I was just wondering, for all of you, that is... we talk about entrepreneurial behavior, entrepreneurship, and to involve students with the companies, but can't we also, what is your feeling of involving in the companies or the industry also with the teaching? Because I think that's very often I see there is, I know some people in the industry, they say, oh, I would love to go to your university and to give a talk. And I know that there are often barriers for this to happen. So how do you think this can work, and how, for all of you, how do you think this could be solvable?
It is indeed lecturing. I think we have a very nice, in Delft, a very nice example in the master, what we call a mentoring alumni program. So we have a mentor. We have, I think, 300 alumni from our university, from our faculty, who are mentoring our bachelor and master students. And it doesn't cost you anything, just you get goodwill. And those people get more relation with the faculty where they study.
Okay. At Charles Sturt, we hired engineers in residence. So art schools have artists in residence, and music schools have musicians in residence. We hired engineers whose either immediate previous or concurrent other employment was as a professional engineer. And so they weren't coming out of a PhD and 20 years of fluid mechanics. They were coming out of doing exactly the work that these students wanted to graduate into in 5 years' time. And the credibility that that brings is incredibly powerful, particularly in a project learning environment, because they will just give you the feedback. Just mentor them like you would junior colleagues at work. Okay. But the links that they bring, and people talk about, I don't understand, how is engaging with industry difficult? Don't you just pick up the phone? Like, to them, it was just weird that universities have this thing about not talking to industry, or if they talk to industry, they go, hello, you're from industry, can I have money, please? Like that seems to be the one question we ask industry. How much money will you give me?
My fee.
Yeah. Whereas if you've got people who are able to think on the industry, because this is industry timelines are much quicker, they're also much more willing to accept a no. Can you help us with this? No? Okay, I'll go and ask them this. But so I think, but what you need is multiple interactions. The idea that it's like quality time with your kids, right? Quality time with your kids is the highlights reel of the quantity time with your children, right? Like you don't get to schedule quality time. You just have to spend lots of time with them and then you get happy memories. Same thing with dealing with industry. You just need to find lots of reasons to be talking to them, engaging with them, taking projects from them, putting cadets on placement, inviting them to events like this, and then eventually the links will come because they get used to dealing with you. And so certainly the projects are great because you can either directly offer them, you can put in your project catalogue, and certainly at Aalborg our project catalogue has industry projects, either industry-inspired project of if this was a real project, they could learn from it, through to this is a real project in our company, we would like you to send us a team to solve it, please. And so that mix of either a copy where there's low jeopardy or a real project where there's high jeopardy. But the short answer is, I've got to be careful. I always say porous, but I think I mean permeable. Be a porous school of engineering. It makes the water engineers angry.
Okay.
It's porous or permeable, I'm sorry, it's not my discipline. But just say, money, people, ideas, they're all going to flow in and out.
Yeah.
Don't worry about, just do it. But I think
Facing up like this idea of understanding the ecosystem and the different actors and how they have different roles and energies and...
But industry has a very different dialect, they have a very different sense of timelines, they have a very different sense of what's going to come out of this partnership. They're scared of different things.
Yeah.
And so having some empathy about what do they want out of this relationship.
Okay. I feel like we've got Professor Falcão Cunha. You've got a question?
Yes, thank you very much. I was thinking about the role of research in these education models, and I remembered a quote that is mentioned as being from Einstein, saying imagination is more important than knowledge. Knowledge is limited, imagination encircles the world. So I've heard some of you talking about the relevance of research, but I would like to get a bit more of your view on this.
It should be teaching oriented. Research.
Are you talking technical disciplinary research or engineering education research?
Interaction between the education process and research at the university. Because we have, our mission is to create knowledge, to transmit it, and to get value out of it as well. But so what is the role of research in improving education?
I think
not research in education, but...
Yep, I understand. I think it comes back to that mission, that if your mission is to serve the communities of northern Portugal, some of that is by solving really hard questions that nobody else is able to, because you have the capacity as a university to have the critical mass of highly talented, capable people to solve these research questions for them. And some of it is by providing the workforce that they need to work in their environments. And so I think you need that range of people who are absolutely immersed in practice and people who are absolutely immersed in the underpinning technical excellence. Because if you want to produce graduates who have this excellence, somebody more excellent than them, the Sheldon Cooper type, needs to come. And as a university, you have the luxury of providing an environment for them. Most companies can't afford to have detailed research agendas because it's a very expensive overhead, whereas at a university it's part of the core business. And so I think we are increasingly going to have a sense where it's a portfolio approach. I think the idea of every academic is a researcher and a teacher and that self-contained unit, I think that's going to be less common. I think we're going to see more of some of our academics are expert teachers, some are expert researchers, some are good at both, some are expert practitioners. But I think that as a knowledge-based organisation, if you want to keep pushing the boundaries of what it is your students are capable of, you need to still be creating new knowledge for them to move into, and you need your student body to know that the people who are teaching them are experts in their field. There's a credibility of having an engineer from practice tell you about practice, but there's also a credibility of having an expert from deep research that you know is pushing the barriers of this field, teaching you that material in fourth or fifth year. So I think there's a place for new knowledge. Where I've seen it work well is when you have very strong links with industry, it's a way of solving different problems for your industry partners. So it's another avenue to engage with them of we can help you with the really hard questions and we can help you with the workforce. So I think it's some problems are solved, you know, there's standard questions that we can solve with standard techniques, and some problems are very hard questions that we need new knowledge. And so you want to have a balance of that. But I think it's going to be more of a portfolio of we as a school can do all these things rather than every single academic thinks they need to do that themselves.
Here between the engineering and possibly the science and things like the arts and social sciences, because a lot of them, they are there and they are very research-based almost from the beginning. So when we're talking about our students and research-based and research-led education, it's almost foreign to us, almost foreign to the students, or the way we treat engineers. Engineers have to know about these subjects and some design and some other things, but actually that idea of introducing them to research is very foreign almost. It's not built in, it's almost a bolt-on. So actually making this authentic throughout the course is quite a difficult thing, because, as I said, people tend to come across the research side when they do their final year project, and that's a bolt-on. Whereas if you look at the arts and social sciences, they get introduced to the literature and the research methodology right from the beginning of their courses. So actually, this is something which we might want to think about differently, is how we can at least show people what the standard is as they go through, rather than bolted on right at the end. It's always been one of my sort of issues.
What about research in education?
Yes.
That's the question. That's the question. Yeah, I can also put questions. Yeah.
Of course you do. Be my guest. Be my guest. Yes, absolutely.
No, but I mean, you are changing your education, and if you want to change education, let's say, in an evidence-informed way, then how do you know? Do you know how you are teaching, how you best can change? Would you have to do research within your own faculty to find out? Do you have research in education? I don't know.
I wonder perhaps if we could put it in different categories, and indulge me with this idea that on the one hand, we've got research as this kind of certification that this organization as top lead researchers that have impact factor and have Q1 publications. And that sort of reinforces outside that kind of organization, as scientific outputs that go within the currency, which is the metrics that we all have to abide to. Then we have the kind of, teaching-oriented kind of research, which is the kind of output that comes out of my research is going to inform my teaching. And in a way, it's a mix of research with science communication, in the sense that it sort of translates intricate and complex scientific knowledge into experiences to the students. It actually tones down the scientific kind of, vocabulary or jargon, and it makes it, palpable, tangible for the students. And then you might have like a third scenario, which is like this combination where you can actually have industry and you can actually go beyond the scenario kind of led and simulation led kind of contexts, and have industry with real life challenges and students actually be involved within a real research project, obviously supervised by senior, and that perhaps as an underlying goal might also inform teaching. I don't know if these scenarios could coexist. Then we come to, then again, we go into the meta post-digital era, whatever it is, post, But so, does this make sense to all of you?
Yeah, look, and certainly one of the advantages we have at Aalborg is that they do a project every semester. So there's no problems fitting a research project in, because it doesn't have to displace. It's not that there's only one project and they have to choose between a research capstone or an industry capstone. We have enough space, enough projects in our curriculum to be able to expose them to different elements like that. And so I think that multiple opportunities give you the ability to build a portfolio of projects for the students.
To make it kind of dynamic.
We had made a different choice. In the Bachelor of Aerospace Engineering, we only had design projects. And in the Master, we only had research projects. That's the choice.
But to get back to what you were saying about research and education, it's very interesting because a lot of the high quality published research and education is very much down the social science line. So it does mean that a lot of us coming from an engineering background have got to either re-educate ourselves or come from that background. So in a way, it's rather, if you were working in a social science, it would be more natural for you to have the skills to do the engineering education. I mean, it's fun. I mean, you know, it's good to learn new things again, but actually you're likely to find people who specialize in that and other people who specialize maybe more in the engineering.
In the teaching and learning lab that they have here, that you recruit 1 or 2 social scientists to do research in engineering education.
Yeah.
How about we cooperate with the social science, the psychology and educational science faculty on these projects?
Okay, yeah, then you do it. Yeah.
But that, you pick up there a theme that is very, let's say, a bit of a thorn for me. There is very often when I'm talking with my colleagues from the educational science areas, they kind of see themselves as the masters of how to educate. And I was like, your way of thinking is completely different from an engineer. And I struggle, although I try to cooperate, I always struggle not to clash with these very often opposing visions of how to educate.
Which is from the other side, is how do we celebrate and reward those people who've decided maybe that teaching and research into teaching is their forte, because
this is certainly one of the challenges in Australia, and I think we're getting a little bit better at it, is promotion pathways for teaching-focused academics. Because, and what we get to is that the promotion panel wants to promote you. They're just not sure, right? Because they know what an associate professor level of research is. They know how many euros of funding that should be. They know how many journal publications. They know which journals it should be in. And then you come to them with this portfolio of the really innovative curriculum things you've done. And they go, they all sound good, but are they really nationally significant? Like, are they really at an associate professor level? And generally, those people are also very articulate, so they make it sound easy even though it wasn't. And so they want to say yes, but they're desperately afraid that they'll say yes to the wrong candidate. And they all got there by their research. And so I think that there's challenges of that they want to say yes and want to support, but there aren't good benchmarks. Now, there are some emerging projects that are giving that. So the Higher Education Academy in the UK has its fellowship scheme. There is an EU-funded register of engineering educators that's getting started now, the Enterprof project. There are things that work. I know myself, an IEEE Transactions on Education Best Paper Award is awesome. And you can see people go, engineering education, is it really research? IEEE Transactions, it must be good. Is it really research? It must be good. Yeah. Which of these is truer?
In the Journal of Engineering Education, they go, this isn't very good, and you go, well, this is.
Yeah, but you know, by going the IEEE route, people were used to seeing the IEEE transactions. And in fact, IEEE Transactions on Learning and Technology has a higher impact factor than JEE. Right? And so there's a certain element of, to build the critical mass, you've kind of got to use the same hallmarks as you would use in a regular, traditional kind of promotion application. And that's why it's certainly very helpful if your National Engineering Education Society runs an awards program at its conference every year and gives you a citation for being really good at doing this stuff. Because you can say, well, a national organisation recognised me for my work. And so I think one of the pieces to support this is to have those frameworks to say, this is how you can have a viable career going down this route. And certainly for radical change, how you can have a career after you leave us. right? Because brand new models are great for people who are in their early 60s already and want to put an exclamation point at the end of their career. But for people who are in their 30s who want to be able to keep feeding their children, like, well, where do I go after I've been to this model? So I think we need to build those. But they can't say, well, your teaching promotion is all going to end up being social science research and education. So I think having a clear sense of this is what your career path will look like if we commit in this way, and there will be opportunities. I think it's getting better because there's more people who have taken this path, so they're not so unusual anymore. But it's not that the panels don't want to promote them, it's that they're afraid of false positives.
It's good to talk about predictions so that I can actually go very smoothly to the last question and go full on Nostradamic kind of mode. And this would be like the big last question to the panel. How do you see, engineers of the future, like let's say in 20 years? Let's go futuristic, let's go for like in the beginning of the 20th century, but now with an extra flair of it. How do you see the kind of an ecosystem of, if we are building up this kind of turning points and paradigm shifts, either self-imposed, either macro-imposed, how do you see the landscape in, let's say, 10 or 20 years?
I wrote a nice book with a nice chapter.
Okay.
And that gives a forecast of engineering education in 2050.
Okay.
So you're welcome to read.
Okay, I'm
a bit disappointed you didn't read, but
Can you just give away the end?
It's their fault. They didn't. I wanted you to promote it. Obviously, I went through the entire body of work.
But that was a very distant view, let's say, on how engineering education might shape. And there it was actually said that faculties, they contain still their siloed discipline, that will not change, but they are feeding their knowledge into institutions where people work from industries, from students and staff, and not based on their discipline, but on the way that they are appreciated by society. And it's maybe a bit too long to explain that in just a few words. But it's a radical different way of looking to a university.
Okay. Good enough is good enough, right?
Thing which I think for the future is that I think it's going to be much more personalised.
Okay.
So I think with things moving online, as we were talking about, picking up your things, the bits that you need, I think we're going to be able to make much more personalised education and teach people how to learn and pick up these necessaries as they go, because we will be so much more blended. So what you want to do is get people to learn to identify what they need to solve problems, provide them with the information to do that. And what you have to measure at the end of it is, are they an engineer? Do they function in the engineering way? So I think that's very much...
That's very self-awareness.
Well, I think that's it, because as engineers and as engineering educators, we have learned to teach ourselves, and we have learned to identify what skills we need. And I think if we can do this to the students while providing enough fundamentals, we're going to create much more flexible, much better engineers.
Yeah, look, I think the Netflix effect, the things that can be replaced by computers will be replaced by computers. And so the delivery of new content, just as there's only 5 textbook producers these days, we'll be in a world where there's only 5 people that give you the videos that teach the material. I think we'll see a much more porous or permeable, I can't remember which, schools of engineering. They won't be the ivory towers where it's only us. That they will have a lot more or at least the survivors will have a lot more interaction with industry. They'll know that mission, and that mission will guide which partners that they work with. We'll see fuzzier edges. And so, I mean, one of the things of a flexible online curriculum is that you can use the first year online modules to support high school students in places that don't have good access to science teachers. And you can use the 5th year modules as professional development for recent graduates in slightly different disciplines. And so I think we'll see a fuzzification of the edges. It's not your life before university, your life after university. I think we'll see a lot more blurring.
Okay.
The other thing, if I had to make crazy, we're being recorded. They'll come and get me on YouTube now.
That's okay.
At the moment, we organise our research around questions and our teaching around answers.
Okay.
The departments are labelled by disciplines, but your research centres are around questions. They're all around multidisciplinary, freshwater or whatever. They're not discipline-based. And so I think we'll start to see that organisation where you still need to have the discipline, but we'll find that the fuzzification will start to reorder things around the mega projects when we get them working.
Okay.
That it'll start to be about all the people who need to deal with these things. I think, and you'd be delighted to hear this, we'll be back to 6-year degrees. Because we're all going to live to 100, so another year at uni is not going to really hurt.
Isn't that going to be good? Isn't it?
Yeah, so I think there's that sense of, and I think there'll also be a stronger sense of lifelong learning, that the 2 degrees are not enough, things will carry on. But I think that essential piece of forming the identity of being an engineer, of understanding what it is to practice, that dialect piece, that engagement authentically with practice, that piece that is the quintessential element that we can't unbundle. I think we'll have that, but I think there'll be so many other pieces that just makes more sense for us to not do. We used to do it ourselves because we were the only ones who could, but I think we'll see it start to evolve out and see it more unbundled. But I think that quintessential piece of what is an engineer and who gets to say that, someone ultimately has to have that authority. And I think universities with our 800-year legacy we'll continue that. I think we'll keep that, but we'll have to, we won't be able to go it alone, and the successful ones will find good ways to do partnerships with others to provide the innovation to keep it moving forward.
Okay, wonderful. I don't know if anyone else wants to resonate on this. Okay, so I think we can call it a day, right? On my behalf, and obviously on behalf of this most wonderful panel, thank you so much, everyone, for flying over to Porto. I hope the rest of your time in Porto is nice. It's not the best weather, I would say, but then again...
I'm coming from Denmark.
Oh, it's beautiful. It's beautiful then. Just enjoy your time. It was a pleasure listening to you, learning from you. It was truly a kind of workshop kind of mindset. I bid you farewell, and I see you in another opportunity. And now let's keep with the protocol, right? Yes. Okay, dokie. Thanks so much.
I'll do it from here. Thank you very much, all of you, and everyone who's here and everyone is listening. I'd just like to say that we have a project that just started on changing the education at the school, aiming at increasing the awareness and the curricular programs regarding the ODS. In English is SDG, Sustainable Development Goals. Okay. And the challenge for the ones who are here and are listening is to learn from this day what they can do, and don't keep just about the current profile of the project. They can change it also. The second thing I learned is that if entry jobs in companies need 2 years experience, we have to give them those 2 years experience at the school, or at least make companies believe that, and students believe that, and we also need to believe that, and if we all believe it, because probably it's true. The final thing is that I sometimes think about the Peter principle. I don't know if everyone knows about it, but the principle says people in a hierarchy tend to rise to a level of respective incompetence, and I believe that this workshop has been very useful for me, for myself, to avoid being trapped in this position. Okay, so because I've got many ideas of what to do, and I'd like to leave my last challenge for the organizers is to write a paper about this workshop and the lessons, the most important contributions it has made for you and for us as well. So thank you very much. all of you, and I hope you have the ones who are returning home sooner or later will have a good trip, except the ones who are at home now who don't have to travel. So thank you very much and best wishes.